Hello, and welcome to AstriCon Plan 9 2020, the 17th annual AstriCon event.
Joshua Culp, proud Canadian software developer, VoIP expert, DNS experimenter, and senior software developer at Sangoma.
So, hi everyone. Welcome to my presentation on a history of video in Asterisk. Before we get started, why don't I go ahead and introduce myself. Hi, I'm Josh. You may also know me as File or J Culp on various places in the Asterisk community. You can find me on Twitter as JoshNet. So at the end of this, if you have any questions or want to discuss anything, don't hesitate to reach out there. I always do respond to any tweets that I receive. I'm a 15-plus year developer in the Asterisk world. I've created many things in Asterisk. So, for example, the video selective forwarding unit support in Asterisk, which is used for video conferencing. I helped create that. I was the co-creator of the PJ-SIP support, and I've had my hands in lots of things in Asterisk over the years. But this presentation is really about video, so let's dive into it and talk about what we're going to actually be seeing today. So video in Asterisk. I'm going to cover how media itself works in Asterisk, what the addition of video in the beginning actually looked like for Asterisk in the early times of it. I'll talk about timestamps, reordering, packet loss, format attributes, video streams themselves, video conferencing, and mid-call renegotiation. And as I'm going through this is actually going to be talking about the journey of video in Asterisk and some of the things that we actually ran into and how we adapted Asterisk to better work in this new world of ours. So let's talk about media and Asterisk. Media is a really important part of Asterisk. It's something that we all use every day. For example, if I call someone through Asterisk, then the media part of Asterisk gets exercised. So there's really two parts of media in Asterisk that I'm going to talk about, and that's when we're interfacing with the outside world. So that's if you're talking to a SIP phone, for example, and then the Asterisk core, so how it deals with that. So channel drivers, such as CHAN PJ-SIP, are actually responsible for setting up media in a protocol-specific way. And for SIP, this really means using STP to negotiate what media streams exist, setting up RTP, and taking care of all that paperwork to actually have media flow externally. And the channel driver is responsible for negotiating media according to the configuration. So this is what the allow and disallow lines are actually for. And it's responsible for sending this information on the channel. And there is no core imposed configuration or requirements as such. Those are really channel driver specific. And so it provides that translation from the Asterisk representation to the protocol specific method as well. So in RTP, this would be taking that payload number, 0 in the case of ULAW, and translating it into the internal representation that Asterisk has, and vice versa as well. As well, the channel driver is responsible for providing and consuming the media. So we give the media over to the channel driver, and it takes it from there and does what's needed. And these are done using what's called frames. So frames contain all the information about a segment of media. The media itself, how much there is, what actual codec there is, all that kind of information. So in the case of audio, that's traditionally holding about 20 milliseconds of audio. And then in video world, it can actually contain a lot of information as video adapts itself based on the actual movement, the bandwidth conditions, that kind of stuff. Internally within the Asterisk core, it only deals with media in the form of these frames. It doesn't really think about things in the perspective of RTP packets, for example, even though the frames themselves may share some of the information that's actually conveyed in RTP itself, such as timestamps and sequence numbers. But to Asterisk, it's just frames. So let's talk about media through the core, and this is for going into Asterisk. So the channel driver reads in the media in some protocol-specific manner. So in the case of Chan PJSIP, this would be RTP. So the channel would wake up and read in the RTP packet from the socket. It would look at the RTP packet contents, do any enforcement of things such as enforcing strict RTP, which is where the RTP stack won't actually allow media that hasn't come from the IP address that it's actually locked onto. And then it turns that information into an asterisk frame. So channel driver is also responsible for notifying Asterisk that it has new media and provides it as the frame is constructed. There's actually two ways that Asterisk can notify, or rather that the channel driver can notify Asterisk that it has media. One is where the channel driver puts a file descriptor on the channel itself, and the core keeps track of that, and if anything is ready to be read in from it, then it calls back into the channel driver. The other method is different in that it's up to the channel driver to do all of the monitoring itself. So it has to, using whatever protocol-specific manner, keep track of whether there's any media waiting, deal with it, and then it in turn notifies Asterisk through queuing the frame that new media is actually available. Once the core is actually told of this, Asterisk reads the frame in and returns it to what is currently handling the channel. An example would be if you are in, let's say, app bridge, then the underlying bridging would be what is handling the actual channel at that time. So it would read in the frame, and then bridge, or the bridging layer rather, would do what is needed with it, such as putting it into the queue to actually get mixed into the config bridge itself. Now, there are cases where there may already be frames, or rather, you may read in multiple frames at a time. And in that case, the core will actually queue those up to be later read. And it's up to the consumer to do what may be needed with the frames. If you're in something as simple as the no-op application, the dial plan, or wait, then it would just read in the frames and essentially discard them. But if you're actually in something like app record, which is recording your audio, then it would read in the frames and write them out to a file. So now we're going to talk about media going through the core and out of Asterisk. So in this case, Asterisk calls into the channel driver providing the frame, which does contain the media and other information. And then it's up to the channel driver to examine that frame and convert it or construct the protocol-specific representation. So as I keep going back to PJSIP, as it is my favorite channel driver, I may be slightly biased. In that case, it would be examining the frame and constructing an RTP packet and sending it to the remote destination. So I've put down here, it sends the media using the protocol-specific manner. So in the case of RTP, like I said, sending an RTP packet, but in the case of something like Chan.DOTI, that would be writing it out to the underlying hardware driver, which would then do what is needed to get that out onto the physical hardware. But how do you know what codec the media is? Because this is really important, because there's multiple different codecs actually supported by Asterisk. So originally in Asterisk, a codec was a bit mask value and nothing more, which essentially represented it as a number. So frames had this set on them to indicate what codec was in use, and everything revolved around this value. The channel driver converted to and from this bitmask value, so taking it from bitmask value, turning it into an RTP payload value, and vice versa. And this would happen every time that a frame came in and a frame went out. And originally, this served the purposes that were needed at the time based on the environment we had. However, video started to appear. So in the beginning, video simply became another bitmask value with no additional information. The only difference was that special logic was added in the Asterisk core to differentiate audio and video for the media path. And this was really done to simplify things, because in the case of video, we don't do video transcoding. So none of that logic was necessary. Monitor or mix monitor doesn't do video, so we don't need to go into those paths. But fundamentally, for most cases, video worked essentially the same as audio, just with no transcoding. So a few codecs were supported: H.263, H.263+, H.264, pretty much what we consider these days the old school codecs, and then the still somewhat popular H.264. And in the beginning, video worked beautifully. You could call people and you could see them. But that sounds too easy, because unfortunately it is. Video is hard. So video codecs, ideally, although they can, don't work in a simple "this is H.264" way. Instead, attributes and parameters are negotiated to better convey what is capable and desired. And this allows higher quality video to occur, and also reduced bandwidth through that actual negotiation. So for those who are familiar with SDP, this is done using FMTP lines, or format attribute lines. And in the beginning, Asterisk did not have support for this. So you could do video, but the quality of it wasn't as good as it could be. And this was really down to the fact that we were communicating our codecs as a bitmask of value with no additional way or information about what was actually negotiated. So instead, what happened was we turned codecs into a numeric value, so no more bitmask, and we added a higher level concept, which we call a format. So in Asterisk, this is an ast_format. For users, these appear as ULAW, ALAW, H.264 in the configuration file. However, in contrast to bitmask values, the format concept also added the ability to include the negotiated attributes. So a format is essentially the negotiated attributes and the codec numerical value. This worked. However, in practice, after we did benchmarking and performance testing, we discovered that it was too slow. And this was fundamentally because it kind of adopted the way that bitmask values were being used previously, and that copying a bitmask is easy as pie and pretty fast. Unfortunately, a format, being a giant blob of memory, is actually quite a bit slower. So when media would pass through Asterisk, you'd be spending a lot of time copying that information around. So a new way was added, so we needed to revisit this and see what we could actually do. So the way that it currently works today is we kept the concept of a format, however, we made it immutable. So this meant that we could pass around a reference to it instead of copying the entire format. So this removed the need to do the copy, except when we were actually changing the format. So that would be if you're actually doing the negotiation in SDP to actually get the attributes of the format. So this proved substantially faster and reduced the amount of work spent on conveying media around a lot. So what does this mean in practice? Well, it means that in Asterisk, one ULAW's format is used for everything, one ALAW format, etc. It's only when attributes are used that a new format is created as part of the negotiation process, and then it's used for the call. So even though we've created a new one, it's still used for that call itself. It's just not shared across multiple calls. The other nice thing about passing formats around is that you know on an outgoing call what the attributes were for the incoming leg. So you can offer that in your SDP to provide a better experience. As well, the format attribute modules, which are pluggable, provide the translation and understanding of attributes for each format, so we don't need to hard code that understanding into Asterisk itself. The other nice thing is that they also provide the SDP parsing and generation. So between ChanSIP and ChanPJSIP, for example, they don't have the logic for understanding H.264, for example. That's all put in a module, and they both share that. So the end result is a better video quality stream. Well, that wasn't too bad, but that's only one stumbling block in the grand scheme of things. So timestamps. In the beginning, we could get away with not actually conveying timestamps in video frames, but in practice, once you start taking video seriously, timestamps are important and you have to pass them through. And they allow the receiver to know how to properly play out the video. Previously, in Asterisk, we would actually construct a timestamp instead of passing it through. The other thing is that a timestamp allows a video frame to actually span multiple RTP packets. So if a video stream is using something like 1080p high HD, then the resulting RTP packets are going to be quite large, and the video is going to be spread across multiple video frames and RTP packets, which will share the same timestamp. So if you don't pass that through, you're going to mess things up, and you're going to convey that the video is actually different frames, while in practice they were the same frame, just spread out across multiple. So yep, this caused issues where regeneration resulted in incorrect value, and the video stream suffered as a result. So we needed to do timestamps. So frames themselves have timestamps on them, so we support setting those on the frame and using them. RTP is the implementation from media level that actually uses this information. And then the core preserves it end to end. And it also ensures that the granularity of timestamps matches up with that of RTP so that they continue to be the correct value. So the end result is an even better video experience. And yes, I'm afraid there is more to this whole video situation. Sequence numbers. So for those who are unfamiliar in RTP, sequence numbers increment for each RTP packet that is sent, and they allow the receiver to reorder packets and to detect loss. So this happens as part of the jitter buffer. And in WebRTC land, it's they call it a packet buffer there as well. And this is very important for video because video has to be decoded in order. In audio land, for some codecs, you can get away with not having the previous packet, but not so in video. Video is extremely sensitive to packet loss. And so sequence numbers are how you can actually detect that. Originally, these weren't passed through, so we would just increment them as we sent them. However, we now support setting and using sequence numbers in RTP for video frames. So when we get a packet in, we will set that on to the actual video frame that goes through the core. The core preserves this end to end. And then on an outgoing side, we can determine when loss occurs and adapt accordingly. So the end result of this is yet an even better video experience. So what I was really trying to get across with diving a bit into those aspects of things is that video is a never-ending journey of improvement. No video implementation, be it Asterisk or other ones that we may use every day, is ever going to be complete, and it's always going to be changing. There's always internet issues, there's always new codecs with new technology coming out. So video itself is something that will just go on and on. So let's talk about video streams now. So in the past, I've done presentations talking about the video conferencing support in Asterisk that we added, and I covered streams in that a bit. So this won't be a complete overview of it, but I still would like to give some information on what exactly they mean. So streams are a representation of a flow of media. They can be unidirectional or bidirectional. So it may be that I am sending video to you, but you're not sending video to me. And in the beginning of Asterisk, it never really had an implementation-specific representation of streams. They only really existed conceptually, and even then, it was only as one audio and one video stream. So this conceptual aspect was due to the work that was done originally to separate the flow out for audio and video. So, like I said, there was no actual code representation of these streams, and in fact, some of the storage of information actually mixed audio and video aspects. So there's a concept of native formats on a channel, which is the negotiated formats. In the original world, that single representation would include both audio and video. So we needed to add stream support to actually do our video conferencing. So Asterisk 16 added an actual defined API for streams and a representation. So this means we have structures of them that contain information, that have the actual negotiated formats on each stream. And if you'd actually like a little bit of insight into that, you can do core show channel on the Asterisk command line to see the negotiated streams and the information about them. Now, one of the things is that for a channel driver to actually take advantage fully of streams, they have to be updated to provide and be aware of them. However, the Asterisk core will transparently allow old channel drivers to work using the old APIs we had. And essentially it put the facade in front of them, which translates how they set formats on a channel into streams, just based on that conceptual understanding that those channels would only have one audio and one video stream. And as well, the Asterisk core will also handle this for dial plan applications and other things. So if they haven't been updated to take advantage of streams, then the core will allow the existing API calls to work just as they did previously. So what's a stream to us? So it's a named entity. It has a state, send and receive, send only, receive only. It has the negotiated formats on it. It can have attributes. So for example, in the case of WebRTC and the ConfBridge video conferencing support, we use stream attributes to allow us to set the label on streams that are given to the browser. So that browser side, you can see which stream maps to a channel in Asterisk to provide a better, richer experience for video conferencing. So streams can be part of a group of streams. This is called a topology. And being part of a topology also bestows a number to the stream, which allows efficient usage. And this is really modeled off of SDP, where the position of a stream in SDP matters. You can't just move them around. In the case of the Asterisk core, it means you can do things like a stream is in a topology at position 0, then I can do an easy method to map that stream to another stream on another channel. Because I can just do an index into array at 0, which then maps to, for example, stream 2 on another stream. So it really makes it efficient of how you're using streams on channels. So what supports them? Currently, the PJSIP channel driver and the Asterisk RTP implementation are the channel side parts of Asterisk that support streams. The ConfBridge dial plan application, so for video conferencing, the dial plan application, as well as the simple and RTP bridge modules. So this covers two-party calling, video conferencing, like I said, and that kind of level of stuff. And then going forward, there may be additional functionality added to other applications as needed to better support things. So what things can we actually do with streams? So video conferencing or outbound renegotiation. So like I've talked about previously, Asterisk 16 added support for selective forwarding unit video conferencing to the ConfBridge dial plan application. And for those who may be unfamiliar with SFUs, essentially you create an outgoing stream to each participant for every other stream. A good example is if Alice, Bob, and Charlie are in a conference, then Alice would have 2 additional video streams, one for Bob and one for Charlie. And Asterisk just acts as a packet forwarder essentially in that case, where a video frame coming in is essentially sent to the other participants that have negotiated that. So to actually support the SFE video conferencing, we needed the ability to change, add, and remove streams on a channel. So the Stream API added a defined mechanism for doing this. However, much like the rest of the Stream API, the channels driver does have to explicitly have support for it. So applications such as ConfBridge can request asynchronously that a new set of streams be negotiated on a channel. And the asynchronous part is important because it's a request that the application, in this case ConfBridge, may or may not see a result from. So it has to assume until things have changed that the current negotiated streams are the way things are. So the application receives a notification if it actually occurs, and it can then go and examine the actual negotiation result. And it's then up to the application to actually use this information in whatever application-specific method is needed. So in the case of ConfBridge, this means mapping the streams out of where video has to be routed. So ConfBridge itself uses this to request new outgoing streams when a participant joins, or it removes them when a participant leaves. And then when it completes, ConfBridge does that mapping from each participant to every other participant. So that if Alice sends her video into the conference bridge, then it gets properly routed to both Bob and Charlie, and vice versa. So what if I want to add video later or do screen share while showing my webcam? So Asterisk 18 added the ability for an endpoint to renegotiate its streams with Asterisk. Previously, there would be no notification given to the application that this has actually occurred. So this was actually done to facilitate this for ConfBridge. So an endpoint can now add, remove, or modify the streams of channel, and then the Asterisk application receives a notification that this has occurred, and then it has to react as it needs. So in the case of ConfBridge, the way it works is that when ConfBridge receives the notification that things have changed, it does a comparison to the old list of streams. And then it does a determination of which have been added, removed, or changed. So once this is done, then other participants are renegotiated as appropriate, as need be. So for example, if Alice is in a conference bridge with Bob and Charlie, and Alice was previously showing her video but decided not to, she can renegotiate to remove her webcam, and then Bob and Charlie will also be renegotiated to remove her. So this also, as a result, removes the limitation of a single video source from a channel. What this means is that you can actually have any number of video sources and they can be added and removed. So you can have your webcam showing your video, you can have a screen share as well, or you can have yet another video stream going into the conference. And the other participants will be renegotiated as need be as those streams are added and removed. So that's pretty cool, but what about normal calls? So in the beginning of Asterisk, streams could only be negotiated at the start of a call. So this meant that if you wanted to do a video call, you had to start that call with both audio and video, and you could not change your mind during the call. So trying to add video mid-call, for example, would fail with no video. And this stems back to the fact that we didn't have an actual stream API or mechanism to do the notifications that things have changed, or provide a mechanism to actually request that things be changed. So in Asterisk 18, alongside the coverage changes, we now support mid-call renegotiation on two-party calls. This is just a fancy way of saying that you can start a call as audio, and then further down the road, if you decide that you want to, you can add video, and we will renegotiate the other party to add the video stream. And the same applies if video is removed as well. So if after a period of time you no longer want to share your screen, for example, then you can renegotiate and remove it, and it'll go away on the other side as well. So multiple video sources are also supported, such as webcam and screen share at the same time, just like ConfBridge. So some other cool mentions of things in video land. So for Asterisk 18 as well, we also added support for streams in local channels. This meant that it also gained the ability to do renegotiation. So if you're a heavy user of local channels in your dial plan, then you can put a local channel in between two parties, and they can renegotiate and add and remove video as needed. And you can also do it for ConfBridge. Great example of this is if you're doing an originate out into the dial plan that once picked up goes into a ConfBridge. You can now actually do this and have the SFU video conferencing work as you'd expect. And we also did some performance improvements for passing video around. And this was specifically done in bridging. We were needlessly giving video to channels that just were not negotiated or needing it. The result of which is that those channels would wake up, examine, and see that, hey, I've got video, but I don't care about video, and just immediately discard. So we've improved things such that we don't wake those channels up needlessly now, which is a slight performance improvement, but it's always good to improve performance when you can through doing other things. So video is cool. I mean, you're watching this on video right now. I think we can all agree in this current world that video has helped us communicate with people and continue life on. But it is hard, and like I previously said, it is never ending. And Asterisk will continue to gain video improvements and become better and better at video itself. So this isn't your Asterisk 1.4. Video in the Asterisk of today is vastly different to how it was, and it's come a long way. A lot of work, some I haven't even mentioned. For example, in the case of WebRTC, packet loss, concealment stuff, bandwidth control, that kind of thing, has gone into improving video, but there's always more to do. So I strongly urge you to keep watch on releases for potentially more video improvements in the future. Thank you very much. Don't forget to follow me on Twitter @JoshNet. Like I said at the beginning, if you have any questions in the future, don't hesitate to reach out there. And I'll also be taking questions after this as well. Thank you.
Hi, Josh.
Hi, Julie.
I love the open source community. They're answering all the questions that have come in on the live stream chat.
I know, until the last minute, and then I'm scrambling to find everyone. Panic.
So it's all yours to elaborate or correct some of the information that's been going back and forth in the chat.
Yes. Hi, everyone. Before I get started, though, I wanted to give a shout out for Dan Jenkins, because he's going to be giving a presentation a little bit later about Dana, which is an open source browser-based WebRTC client for Asterisk that you can use for the video conferencing support in it. So stick around and be sure to watch that and ask him questions as well. But I will go through my list of questions, which are still coming in here, and try to answer them before the time runs out. It's a challenge. So first off, let's go for video conferencing means how display will look like. So what a video conference in Asterisk looks like is dependent upon the client itself that's in use. So that would be the, for WebRTC, the actual JavaScript, the HTML layout, that kind of stuff. It's responsible for actually positioning that on the screen. So a common approach is to make something like Sangoma Meet or Google Meet and have that kind of experience. So it's really dependent on the client itself. Asterisk itself doesn't dictate that. So what is meant by a stream? A flow of RTP into and out of Asterisk. Matt Fredrickson answered this a little bit, but I'd just like to elaborate that within Asterisk itself, the core, we don't think of things in terms of RTP in that. So when it comes to streams for us, I like to think of it as just media flowing. And then, is there any notification via ARI if a channel changes media format? You spoke about Conference, but not what happens if you use ARI, where you do these kind of control by yourself. If the media changes, you need to add or remove capabilities of the bridge. So currently, there's no events that occur when this happens, when renegotiation occurs. The most you can do is set up an SFU bridge, and then you don't currently have much control of that within ARI, unfortunately. But those are certainly things that in the future would be great to see, to actually give ARI developers the control that that they would like within ARI. And then here's a reminder to Dan Jenkins: remind yourself to ask about external media for video as well as audio. Here's a question: do the applications handled in FreePBX like ConfBridge currently handle video streams and renegotiation in Asterisk? So there's nothing special about the Asterisk in FreePBX, provided that ConfBridge is configured to actually do SFU, then it will behave as if it were a FreePBX or not a FreePBX. So can we assume Asterisk is SIP plus video only? I think Matt answered that as well. Naughty Matt, answering questions instead of me. So yes, as he stated, SIP, or specifically PJ SIP, is the channel driver that is used for all of this. So it gains the more advanced WebRTC functionality, stream support, and in the future, as additional stuff is added, it will also gain additional functionality. Let me go back up here. VP9 are supported by Asterisk. Any plans to add video recording for those formats? While there's not currently plans for that, it's certainly something I'd like to investigate, but not from the perspective of recording VP9 specifically exactly. File playback and recording in Asterisk is one of the areas that has seen little change essentially since Asterisk itself was created. So it lives in a world without containers that we all use probably every day, such as MKV. So really to bring that into a world where video is a first-class citizen, and it would also, for example, if we did do containers, it could also add the ability to record video conferences themselves and allow that to be played back. So that would be quite cool. Let's see what else we have here. Oh, someday the codec negotiation changes in the Asterisk 18. Is that working the same for the video codecs? I believe that it should also work for video codecs as well. So if you place an outgoing call somewhere and or it will rather, and it would answer with H.264 with certain format attributes, then that would get traversed back. Thoughts on using ChanSIP for WebRTC and video? I feel like PDSIP does it better, but I've made both work. So ChanSIP can be used for video to a degree. You can use it for a single audio and a single video stream. ChanSIP itself has no concept of, I won't say no concept of streams exactly. It doesn't have the latest support for streams that are represented in Asterisk. And whether it continues to be supported for both audio and video going forward is kind of dependent on the browser. That may change if they require the audio and video to go over the same RTP port, essentially, which ChanSIP does not currently support. For anyone wondering what that's called, it's called bundle. It's where you bundle all the streams together into one. Let's see here. I did YouTube chat. Let's go over here. Okay. Bill, Simon, can Asterisk smartly deal with legacy SIP clients non-multi-stream capable connecting to an SFU bridge? So right now, smartly depends upon your definition. It will receive video from a legacy SIP client, but that legacy SIP client will not receive video from anyone else. And that's because Asterisk itself does not currently do video codec translation, manipulation, etc. However, the architecture of Asterisk itself means that if one day someone wanted to go down that path, it's possible that it could be added in, but it's not there at this point. How does the FMTP lines in SDP look like, and do I have to add them manually via the Asterisk style plan? So, so you don't need to worry about FMTP lines at all. We will generate them ourselves. We will negotiate them ourselves, and we will communicate them. There's Matt actually not answering someone. Thank you, Matt. Is there any questions over here? Okay.
We probably have time for one more question before I ask the final question.
Oh no. Let's see here. That was answered. Well, for the final question, I will say, if I don't answer your question now, don't worry. I'm in all places, so you can reach out in the places and I'll answer them there. So why don't you ask your question, Julia?
So there's a lot of interest in your hats. So what made you choose the Stetson today?
The answer to that is the Stetson is a rather large hat, and so it's hard to travel with it. And so I thought, why not? Since it's unlikely I would ever wear this to an AstriCon, and it is so large that I've kind of hid it on my refrigerator earlier and the door. So it's a big one.
Very good. Well, Josh, thank you so much. It was a great presentation. And like Josh said, he'll be in the chat rooms and he'll be answering any questions you might have. So thanks, Josh.
Bye.
From my wife's favorite store, Target, please welcome lead engineer for Target, Jason Park.
The Great Migration. For those of you who don't know me, I'm Jason Park. I've been working with Asterisk since 2003. Probably followed a similar path to lots of people watching this. Worked for a company, we needed a new phone system. We didn't really like the value proposition that a lot of the commercial offerings provided. And we used our open source background and found Asterisk. And I guess the rest is history. But I've been working with Asterisk, like I said, since 2003. A DCAP I received in 2011. Work with Camelio, OpenSIPs, FreeSwitch, all the different types of open source telephony that's out there. I've been working with open source in general since 1995. And I lived in Missouri for a long time, but now my family and I live in Minnesota. And we came here to work with Target. Target brought me in May of 2018 to look at ways we could use open source voice to replace some of their legacy proprietary voice systems. Specifically replacing Cisco Call Manager that they were using in stores and distribution centers. And it's what I've been working on for the last couple of years. If you were able to see my presentation last year, I talked a lot about the architecture of the solution that we've put in place at Target. This year, we're going to talk about a different piece of it and reusing Cisco endpoints, but we'll have a little review about the architecture and things for some better understanding. But if anybody'd like to see that presentation from last year, my contact information is here, and I'd be happy to provide the presentation or answer any questions about it. So here's what we're going to look at today. We're going to go on a little quest here. We're going to learn about the mission. Then we're going to look at the relics. We're going to look at all the different Cisco endpoints we're dealing with that we had to convert. We're going to look at the old ways. How would we have done this even 2 years ago? And how are some people doing it today? Before we look at how we actually did it, we're going to talk about the heroes and the team we put together and kind of the unique way we put the team together to do these cutovers and conversions. And we'll talk about the way of the wizards, the new way, and how we accomplished cutting over stores. Then we're going to talk about some of the magic we used, the migration tooling that we've put together, and what we call the provisioning bridge. Then we'll look at what treasures we found and the tribulations we had along the way, and talk about the takeaways. And then if anybody has any questions, I'll be happy to answer them. We'll hold a little court. All right, so the quest, requirements and goals. This is a bit of a summary, but the core requirement was we had to migrate from Cisco Call Manager to our new platform that we call Hydra. Just as kind of an overview, uses Asterisk, Camelio. It's radically decentralized. We have about 2,000 virtual machines running this. And with a little Asterisk virtual machine in every one of our stores, of which we have about 1,900. And we did a lot of feature removal. Cisco has lots of features. We only used less than 10 of them, so we did a lot of feature removal. The next requirement we had was to minimize the impact to target guests and team members. Now, this was important a year ago, but as we entered a global pandemic in the spring, it became even more important. Suddenly, our team members and our colleagues that are working in the stores were on the front line of the pandemic and being there to address the needs of our guests in a new environment. And so, as important as it was before, it was suddenly much more important that we minimize the impact of any transition we did as much as possible so that those team members could take care of our guests' needs as efficiently and easy as possible. And if we weren't able to, we would have had to put the project on pause until this global pandemic was over. As part of minimizing that impact, we decided to try and reuse Cisco endpoints, phones and gateways whenever possible. And that let us minimize the number of truck rolls we had to do and how many technicians we'd have to send out of store. And we also had to automate as much as possible. I'm sure lots of us in the audience are engineers and developers. We know that a lot of our work these days is taking a project, automating as much as possible before we move on to the next project. So that was definitely a core tenet. But to do all of this, we had to tame the Hydra. We call the project Hydra because we have one of these VMs in every store. It's multi-headed, and if we don't manage it right, it could be a monster. So let's look at our relics. And you may think, I see what you're doing here. You've got a Quest and relics. Some of these Cisco endpoints are old enough that I'm guessing that if you looked at them, you'd call them relics too. We have over 15 different models in use in the stores today. Those are just Cisco models. We have multiple analog gateway models. Every one of them has different challenges of their own. Some of them fit into groups of phones like the 7900 series, etc. But they all have their own challenges. They also present a lot of provisioning challenges. Some of the models we're working with, and all of these, we have over 1,000 of these endpoints out there. Cisco 7905, out of 15 models, this is the only one that uses a binary configuration file. So it was a lot of work for one single phone model. Cisco 6921s, these phones are fine for what we're using them for. They got a little screen, but they take over 20 minutes to reboot and flash software. And so that provides its own issues for us during a cutover. The Cisco 7900 series, I'd be surprised if there were a lot of people watching that haven't touched one of these at some point in their career. Very solid hardware. You can drop it over and over. It'll keep ticking. The SIP stack on them has some challenges, but a very solid piece of hardware. And something like the Cisco 6901. We use these as kind of wall phones mostly. They don't have any kind of screen, so troubleshooting any kind of issue with them is a little difficult with very limited indicators of what's happening with them. So those are the relics. Let's look at how we would have done this 2 years ago, the old ways. And when I say this is the type of plan we put together 2 years ago, even as we were still building the architecture that we built, because this is the way we had done it before. And you'll see it gets a little complicated. We'd start off with a physical site survey. This means contracting with a third party to send technicians out to all 1,900 of our stores. They would have to schedule time to meet with a store director or some other type of representative on our side at the store, which is difficult, especially during a pandemic. They would have to gather information about every phone in the store, what type of phone it is, what's the extension, who uses it, how many analog lines are in use, how many analog gateways are out there. All of this type of information that they would do in person, on site, and document in some type of spreadsheet or something. We'd also have people remotely working to document endpoints and information out of Cisco Call Manager, and then taking that information from the physical survey and the virtual survey and putting them together and applying our business rules. These business rules, some of them are pretty simple, but it's things like, we don't use this extension anymore. We try to keep our stores as cookie cutter as possible. And so if we have an extension that hasn't been used for a long time, it's deprecated, during this cutover process, we'd want to change it to what we would normally use. And so they would have to apply those business rules to the documentation. And once that's done, we can start configuring things in the new system. Either copying and pasting out of the documentation into the new system, putting it in the database, putting it in a web interface, whatever it may be. Maybe even an import. We also have remote engineers that are doing back-end work during all this to get it ready and are available during the cutover night to do things like SBC changes and route changes and different things like that. But we'd also have to have on-site technicians at the store the night of the cutover. So we're already up to 2 store visits and 3 different teams here. A team to do the survey, a team to do the on-site work during the cutover, and a team to do the remote work on the back end. But we also have to make DHCP changes. And at Target, that's a different team that we would have to coordinate with to do these changes. At the peak of our migrations, we were doing 21 stores a night. So we would have had to get at least one resource from that team 4 days a week when we did cutovers to do those changes for us as a hot cut. And we got to reboot phones. We can do that remotely, or we could have the on-site technicians do it. We got to monitor the firmware flashing, which I said could take anywhere from a couple minutes up to 20 or more. Once the phones flash, we got to monitor the re-registration and complete all of the back-end work. This may be one of the busiest slides I've ever put together. And actually, before I put these circles on here, I had it all in text and it just looked like spaghetti. And I think it does it justice of how complicated and how many steps there are and how many teams would have been involved if we would have went this route as part of our migration work. So we won't talk about how we actually did it yet, because I want to talk about the team we put together to actually do the migrations, what I'm calling the heroes. So we had to do hundreds of after-hour cuts. We're doing it to what we had built as an open source, from open source tools, a platform for us to use. A lot of it has our business logic and things in it. So there isn't, outside of our small team of engineers, there's not resources on the shelf to grab from of individuals to do this work. So it's all built on Asterisk and Kamailio. We could have went out and found Asterisk experts. Could have went out and found some Kamailio experts. Probably could have found some analysts and did some upskilling for them to help with the project. We could have taken some technicians and maybe did less upskilling, but we went a different route. We had some resources that had done some migration work for us before, as little as 2 years ago, converting some of our distribution centers that weren't on Cisco yet from other legacy systems to Cisco. And they are Cisco subject matter experts. And it was an interesting path getting here. These folks, I still remember sitting down and talking to them about the project to see if they were interested. And one of them said, "You don't want me. You don't want us. We're Cisco experts. You're moving off of Cisco. This doesn't make sense." For us, we knew the new system very well, and we had built it to be as automated as possible. And we also had expertise with Cisco, but these resources spend most of their career either cutting over from legacy systems to Cisco or upgrading from one version of Cisco to another. They're very good at documenting and building a process, documenting that process, executing on the process, and providing a good experience for the entire cutover. On top of that, since we're reusing Cisco gateways and Cisco endpoints, they're experts with that equipment. And it ended up being a really good fit for us. And I think they learned a lot about the open source side of things along the way. So we put together a team. So how do we actually do it with the team and our automation and things? Well, we had to build some migration tooling for automation. We'll talk about this a little bit more in depth, but this was all a web-based piece of tooling. All of our we still had to do a site survey, but that was done completely remotely without any truck rolls, using that tooling and our business rules. And this was all by this remote engineering team that we put together as Cisco folks. any needed changes we needed to make, we did before the cutover on the Cisco call manager side. So if we had a business rule that said this extension's a duplicate, we're changing it to this, whatever it may be, we made those changes in Cisco before the cutover. This really helped soften the impact of the cutover, and it also kept our data from going stale. So even if we're doing this a week or 2 weeks before the actual cut, if we're making the change in Cisco, it's already there and ready for us on the cutover night. It also helps our team members, because if we're changing something that affects them, it's only going to be 1 or 2 phones before the full cutover. So if there's a problem or we need to adapt and change, we can do that before the full cutover. We're also able to do the DHCP change weeks prior to the cutover. Like I said, and what we originally envisioned was going to be a hot cut the night of. This allowed us to submit all of the DHCP changes for up to 4 or 5 weeks ahead of time. And that really made things easier for us. And again, it allowed us to keep the work into one team and not have to involve other teams. The remote engineers performed the cutover too. So we had one team doing all of our site surveys, making any changes they needed to do, and doing the actual cutover the night of. And they did that completely remotely. To give you an idea, they were in, we had one engineer in the Mountain Time Zone, one in Central, and one in Eastern. That wasn't really done with a big purpose in mind, but it definitely helped us cover all the different time zones we were in. We converted stores everywhere from the East Coast to Hawaii. So let's talk about some of this magic we use. Specifically, we're going to start by talking about the migration tooling. Now, we already had a web interface that we built to manage this system. And, you know, we talked about the heroes, but I'd be remiss if I didn't mention the engineer on our team that put together our web interface to manage this. Basically owned our legacy Cisco product for the stores and distribution centers. He had done some development, but he was not a web app developer. But he upskilled to do this, and so he is definitely one of the heroes to mention in this. And this web interface we had was mainly used to manage the system, add phones, make all our moves, adds, changes, and also used by our support partners that support team members when they call in with any kind of issue. And so the migration tooling was just a module that we added to the system and was also all web-based. We were able to integrate with the Cisco AxleScript API to get all our data. It is a SOAP-based API, not exactly RESTful, but it works. And it allowed us to get all our information about device pools for different stores, information about individual phones along with MAC address and configuration and extensions. And it also let us get information about the voice gateways we were dealing with and what ports were in use and what they were used for. And we couldn't have done the automation we did without that API. The engineers did all of their remote site surveys using the API, using the tooling. And in some cases, they had to apply business rules themselves, but as much as possible, we baked the business rules into this process. And then when we got to the night of the cutover, they would literally hit the big red button. So by clicking the button, they'd gather fresh data from Cisco. So we were able to avoid config drift because we're getting the freshest information and at that point in time out of Cisco. Insert it into the new platform. Some of the business rules would get auto applied there, and then we'd hit that same API to reboot the phones. And at that point, the engineers get to sit back and monitor the results and clean up any hanging issues. At the beginning of this process, they had to actually configure the voice gateways by hand, each of them. Most of our stores have 4 to 5 gateways, 24-port gateways. But as we went through this and we iterated through and added more automation, we were able to automate that as well using Ansible. So their job kept getting easier and easier, and they kept being more and more thankful of the automation we were able to put in. And they could really focus on the fringe individual case problems that would pop up in a migration like this. And they were able to do that all remotely as well. The second piece of magic we're going to talk about is what I call the provisioning bridge. If you've got a better name for it, feel free to toss it out because it's kind of boring, but it does a lot of cool stuff under the hood. Part of what we had to do with our provisioning system was both provide support for our newer device standard, which today is polyphones and audio codes gateways, but also those Cisco relics we talked about. I'm not the type of person that really likes to have thousands of static configuration files laying around. So we really wanted to be able to support this with one code base dynamically. With all these different types of devices, we had to be able to plan and be able to provide for configuration and provisioning using multiple protocols. And part of that fell into DHCP. I know I've mentioned DHCP different times so far and how it was a challenge and when we do it. To give you an idea with the polyphones, it's a very modern standard of the DHCP option is a full URL in the tag, HTTPS, whatever it is. Makes it very easy for us to use a host name, point it to the load balancers that we use for all types of other services at Target, and make this provisioning service very resilient. Cisco works a little bit differently. First of all, they only accept IPs. They do thankfully allow for an array of IPs, so we can do some nice failover there. But there's definitely some challenges in the differences that these different technologies use. The big thing is dynamic mapping of all the protocols, and especially the older protocols. To get to that single code base that could use templates and data out of our data store in real time to provision a phone, we had to do some custom tooling to map different services that the phones use to provision into our single system. In our case, it's Python based using Flask, and it today is serving all of our new devices and all of our old devices for provisioning from a single code set. We talked about doing DHCP weeks before, and this is we call this proxying. It's pretty simple. Before a store is cut over, it's marked in our database as still on Cisco. And when we change the DHCP tags weeks before, and the Cisco phones, even though they're not on the new system, start hitting our new provisioning system, and we look at what store it's coming from, and if it's still on Cisco, we figure out which one of our Cisco clusters it goes to, and we map those connections on through to Cisco. So it does add a step in the mix. It doesn't slow it down much, but it gives us the flexibility to do this ahead of time and change the DHCP. On the night of the cutover, when you hit that big red button, it literally flips that flag in the database, and when those phones get rebooted, they start hitting the new provisioning server. So what did we learn along the way? Well, this is a summary because we learned a lot of stuff. But I mentioned those 6921s take 20 minutes to flash. When we were doing the first of these stores, and we were worried about this project being ground to a halt as we looked at the ongoing pandemic, when you've got phones hundreds of miles away sitting for 20 minutes, I'll just say that patience is a virtue, and you start to figure it out. Some of the relics used entirely different configuration schemes. Those 7905s I talked about, they use a very specific binary scheme. We have to create a text. If we want to be able to do this on the fly, if anything changes, we have to create a text template, then we have to build it into the binary format it needs, and then pass it on. So we have a plan to replace all of these Cisco phones in the next few years. But with the way we've done this, we've been able to put that in stages, so we didn't have to do it when we did the cutovers and do a bunch of truck rolls. But this was the different configuration schemes and things were definitely a challenge. We can definitely do all this work remotely. We did, out of 1,900 stores, we've completed over 1,000 stores. So that's over half our chain. We did one store completely on site. We did a couple of stores where we did them remotely and then came on site to make sure they all worked the next day. And after that, everything was done remotely. So you can do it remotely, and you can do it remotely and still provide a great experience for the end user. Because of the automation we did, we were able to have that one team of engineers. We had 3 of them, and they got up to doing 84 sites a week. They were able to not only do the site survey and any changes they needed and the cutovers, but they were able to do the communication with the end users and the applicable contacts at the store and handle the whole thing from end to end. And that was really nice because it allowed myself and the other engineers on my team to focus on making the tooling better and to apply more business rules and automate as much as possible. You can also teach old dogs new tricks. I mean, we took Cisco engineers here and we taught them, we threw a lot of new stuff at them. They already had tools for doing this in a Cisco environment. They didn't have tools to take off the shelf to use for this. They had to use the tools we had, and they had to learn some new stuff. But I think it was a good experience for everybody. And it's been very successful. They will start finishing up the remaining stores after we're done with our peak season in January, and we'll continue to get everything moved over to the new system. So with that, I'm ready to hold court. If you got any questions, I'm happy to answer them, or at least try to answer them. My contact information is here. Again, if you'd like more information about the architecture we put together and how it's different than a lot of the enterprises out there today that are going to centralization while we're going the other direction, I'm happy to share that presentation and answer any questions on that as well. And I appreciate your time today.
Hi, Jason. That was a great presentation, and thanks for being here.
Thanks, Julie.
So we had that came in. I think you've seen them on the live stream, and I have some for you that came in during the on the Slack channel. So if you want to go first.
Sure. First of all, a disclaimer, my presentation methodology had nothing to do with the Asterisk's sorcery mod, just to throw that out there. And I don't know if Fred or anybody else from the Camelio team are listening, but I apologize for continuing to introduce new pronunciations for their project. So now I saw a question from Danny about new Cisco phones being much easier to work with. Completely agree, but the older Cisco phones are a lot more exciting to get cut over. So that's what we focused on today. But we do have some newer Cisco devices out there too, and they were definitely, as you said, much easier to handle migration with. I saw a comment from somebody about my phones in my office, and I can tell you, to Lauren, I can tell you that Mrs. Park agrees with Mrs. Lauren that teetering piles of SIP phones can outlive their usefulness. So keep up the work of downsizing those. To give you an idea for our Cisco testing as we worked on this project, we literally had an official Target shopping cart that we had all of our Cisco phone models piled inside of, that's sitting in our lab at the office. So lots of old gear to work with. And I think this got answered in the chat, but Duncan asked about DHCP changes we were talking about, and it is for phone provisioning and the DHCP tags for those. VG224 devices, somebody asked about supporting those. We are supporting those, an entirely unreasonable number of them that we have deployed, in my opinion, but we have multiple VG models that we're supporting and that we cut over, including the VG224. And I see a question here from Jason Parker about whether we can duel for ownership of our names. I can say that I spoke at AstriCon when it was in Denver, and I think our names got mixed up in the program. And then one time in Orlando, I tried to check into the hotel and they said, no, you're already checked in. And I said, well, that doesn't make sense. Jason Parker had checked into his room. Jason Park had not. So this is just an ongoing saga of names. Somebody asked about the main purpose of the migration. And they asked if it was cost, stability, features, and it was all of those. It was simplification. We have Cisco Call Manager has thousands of features that our team members in the stores don't use. So we were able to simplify and implement the less than 10 features we actually needed. There was also cost savings and stability and a good path forward when we wanted to introduce new features, to be able to own that that workflow and introducing new features ourselves instead of relying on an outside vendor. Let's see. Answered that. Store-to-store calling isn't something that really fits into our business rules. We handle it a little different maybe than other retailers and other companies and other verticals. But we handle that by making sure that any team members that have to call another store go through the entire process that a guest would. So that really isn't in the equation for us. And I got another, let's see, Duncan's got a question about Kamailio versus Asterisk, and I presented on this last year just to kind of give a quick rundown of our architecture. Previously, we had Cisco Call Manager living in our data centers, multiple clusters of that, very centralized. In the new architecture, we have Kamailio running in the data center to do kind of a proxy layer, and it handles our call routing inbound, it handles outbound call routing, it handles our E911 process, and is basically just a great traffic pump and dispatcher of SIP traffic in each direction. It sits between our stores and our SBCs, and then we're using Asterisk in the stores. Very small virtual machines in every store where the phones actually register to and do that very limited set of features that we actually need. Oh, this is a great question. How do you interface with the red guest phones? This is we love these phones. We love these analog phones that we have to deal with every day. The red phones today integrate using a separate third-party system to talk to our radios. But if you've been in a Target store recently, and I definitely recommend you you visit Target stores as often as possible. If you've been in a Target store recently, you'll see our team members carrying around a mobile device, where we've moved a lot of calling functions to. There's a soft client on there, and which is a big part of our newer architecture as well. And so these lovely red phones are starting to get phased out, and they're only in less than half of our stores still, so they're being phased out. I think that's all I saw, unless I missed something.
And I think you answered the question we had in the Slack Q&A, so.
All right.
That was good. Jason, it has been a pleasure to have you back with us again. Love Target. And
appreciate it.
It's become the $100 store in our family.
I love to hear that. What can we do to make it your $150 store?
Great answer. Well, thanks for joining us, and we will see you soon.
Thank you.
Say hello to Dan Jenkins, Nimble-Ape CEO, founder, and engineer.
Hi, everyone. So I'm going to talk about I am the gatekeeper. And you all might go, well, what the hell is Dan talking about? I mean, let's get to me first. A little bit about me. So I'm Dan Jenkins. I'm the founder of Nimble-Ape Limited in the UK. I'm the organizer of something called ComCon, which is an RTC event in the UK. I'm a massive, heavy coffee drinker and whiskey drinker. Whiskey with a E. So that's primarily Irish whiskey. Love Lego, and I love open source software, especially Asterisk, FreeSwitch, open source telephony. Dan_Jenkins on Twitter, and Dan Jenkins on GitHub. Nimble-Ape, very, very quickly. So we're an RTC consultancy in the UK. We've got clients all over the world. We do an awful lot of open source VoIP, telephony, / WebRTC / anything that kind of deals with real-time communications, whether or not that's like native apps on a phone or adding web type stuff into your existing telephony system, for example. We're the primary sponsor of all things ComCon because I spend all of my time doing it. And yeah, we support loads of open source solutions that enable us to help our clients. And then we also create our own as well. And that one of those is what I'm going to talk to you about today. And of course, we're a big supporter of Asterisk. So I am the gatekeeper. I mean, catchy title. It got you kind of looking at it and going, oh, this is quite interesting. What the hell has gatekeeper got anything to do with Asterisk? So yeah, what am I talking about? I'm talking about Asterisk with WebRTC and the power that is built in within Asterisk. Ever since Asterisk 15, I think, there's been something called the Asterisk SFU. And basically that enables us to create some really great solutions using just Asterisk. So gatekeeper, where am I going with this? Well, you'll find out in a minute. So WebRTC has this concept of streams, right? Keep going, like it's a tangible link here. So WebRTC has this stream concept. So you can see there, the green lines are video streams and the blue lines are audio streams. And we've got loads of different streams, different numbers coming to and from Asterisk from different browsers. So WebRTC has streams. But I mean, when we talk about streams, what's the first thing that comes to your mind? Well, it's don't cross the streams.
I love this plan. I'm excited to be a part of it. Let's do it. The job is definitely not worth another $5 a year. Hurry! See you on the other side, Ray. Nice working with you, Dr. Frankman.
And the Marshmallow Man gets destroyed because we crossed the streams. So every project needs a cool name, right? There's a reason why Asterisk is called Asterisk. So any project needs a cool name. So first off, let's introduce Dana. I mean, if we're talking about gatekeepers of streams, it should really be called Zool. But there's a really cool project called Zool, and the Asterisk project uses it. So I couldn't use Zool, but Dana Barrett in the film becomes Zool. So the project is called Dana. It's called Dana the Stream Gatekeeper. But what is it? So let's tell you a little bit of a story. Once upon a time, many years ago, exactly, 4 years ago, I think, there once was a project called Cyber Megaphone 2000, and it was a front end for Asterisk's SFU, and it was hideous. It looked something like this. It looked like this because it was never meant to be a solution that someone actually went and built with. It was meant to show off how to build something with Asterisk's SFU. There's a reason why there's boxes and it just doesn't look very friendly, because it's never designed to actually go in front of anyone. But ultimately, it didn't show off how to go and build modern day applications using Asterisk and web technologies. Kind of just shoved everything in. It was one big file of JavaScript. It's really difficult to actually kind of follow how to build something. It looked terrible. And like from a code perspective as well, it was really difficult to kind of follow and get started with. So yeah, that's how I felt as well the very first time I looked at it during an Astra DevCon. Sorry, the Asterisk team. I mean, it served its purpose, right? But ultimately, we needed something better. So that's what we went and did. But Dan, what's an SFU? I hear you crying, hopefully. An SFU is basically, well, it stands for Selected Forwarding Unit. And it basically means that we take streams from a participant and we forward those streams selectively to other participants. Asterisk's SFU isn't really a total SFU. It's actually a video SFU and an audio MCU. And this is where we go back to this diagram that I showed you earlier. The green lines are video and the blue lines are audio. And so in a typical SFU, almost one-to-one, you should get the same number of blue lines as you do green lines. Almost. But in this case, you can see that we're actually sending up audio and we're only getting one audio stream back. And that's because Asterisk acts as an audio MCU. But this is the cool thing about an SFU. You can get you get given all of these individual streams and we can do what we want with them. The other way of doing this that you might have heard of is called an MCU. And it basically mixes everything together. And so there would just be one audio stream going up and one audio stream coming down, just like we've got here, but we would be sending up one video stream, or even maybe more, but we'd be getting back one video stream because it would be mixed by the server. Whereas Asterisk doesn't mix anything other than the audio, and it just passes on all of those data packets with all the video so that we can do stuff in the front end. And that's where Dana comes in. Last year in Atlanta, we were talking about the need to fix Cyber Megaphone / build something. And it was the very end of the conference. And I remember Matt Frederickson standing in front of me saying, "Oh yeah, Dan, it would be really great if, that thing existed." Because I'm a web developer and the Asterisk team aren't. So I finally said, yeah, let's do it. And come November, so about a month after AstriCon, maybe a little bit longer, 6 weeks, we launched the very first version of Dana. And you can see it here. we've got dark mode and we've got light mode, depending on what kind of browser, what kind of what mode your OS is in, or what mode Chrome in this instance is in. And it does some wonderful web things. And so you can go take a look at the code, the links there, and you can go and it's all built with React, modern web frameworks, React, Webpack. Everything's written as components, and then everything gets bundled up properly using Webpack, and then outputted to the browser. It's a great project for getting started with Asterisk's SFU. So the issue here was that Dana was meant to be like this front end to Asterisk's SFU, and to give people an idea of how to get started with Asterisk's SFU. But ultimately, it became more like a showcase project, mainly because I wanted to play around with cool new things in Asterisk that suddenly enabled me to do these cool new things. So I wanted to play around with that, and Dana ended up being a great place to do that. So before, the very, very first incarnation of Dana used ConfBridge. ConfBridge is built into Asterisk, and it's just a conferencing bridge, and you add people in using your dial plan, and magically we get this conference bridge, and we get video streams, and we get SFU kind of just for free, and that's great. But ultimately, how we build applications today, fresh applications where we want deep integration into other tool sets, we generally build ARI applications now. So I wanted to go and show people how to build an ARI application. So I added a conference bridge written in ARI and Node.js. The link is there at the bottom. That's cool, and it shows people how to kind of get started with the ARI and the kind of concepts that we use to build things. But then this new thing called external media got released last year, that enabled people like me to take a stream of RTP out of Asterisk without having to know C or anything like that. And I could just get it out and do something with it. So I added speech to text inside of Dana, which is actually really useful because you're on a conference call and now you get a live transcription of what everyone in that conference is saying. And it's not just one, the way that we did it, I'll show you the code in a bit, but the way that we did it was so that each individual person in that conference bridge has their own individual link up to, say, Google in the first instance. So we know categorically that Dan said A, B, C, D, and we know that Fred said X, Y, Z. And that's really quite powerful. But we didn't stop there. Then Asterisk added in support for multiple video tracks. So before, we needed to be able to, if you wanted to be able to do, say, screen sharing in a conference call, as well as having your webcam, because that's great, like being able to see someone talking in front of you and their slides and how, like right now, you can see I'm playing with my hands, I'm doing stuff. And so ultimately, body language has this huge impact. And so we want to be able to show both. And before, you had to have like this separate video call, this separate dialogue, basically. And that became very complicated because then you had to figure out which of the video streams you were getting back was this track that I was actually sending up in the first place. Anyway, it was very complicated. It wasn't perfect. And so earlier on this year, the Asterisk team added support for multiple video tracks. And so now we've only got one peer connection, WebRTC connection up to Asterisk, but Dana supports being able to send both a screen share and webcam. So that's really cool as well. And the link to the blog post is below. Then we added support for chat. Thanks to George from Sangoma. This isn't chat through some other means. this is chat through Asterisk using SIP messaging. So that's pretty cool as well. And then literally last night, I was like, what cool stuff can we do for this talk? I went and added support for another 2 speech-to-text engines. And I'll show you the code in a bit. But essentially, we've added support for Azure Cognitive Services and Amazon Transcribe. So now we've got Azure, we've got Amazon, and we've got Google as potential speech-to-text engines. So now we can have this 3-way battle to the death of transcription, which is pretty cool. I mean, when I wrote this slide, I know exactly which GIF I want to go with this. Jim Carrey and me, myself, and Irene. Anyway, you can see here we've got a battle to the death. We've got Dan Jenkins, it's the name of the person, so me, and then in this case I've added which provider we're getting audio, we're getting transcriptions back from, and so you can see this this battle between all 3 of them. So I was working on this last night and I was playing music, and so that's why some of I want a grateful, I don't want to obey, that was a song. But me saying I love bread, I love Fred, Fred, that was me. I mean, it's true. I really do love Fred, and you should all check out apiband.org. But I mean, Dan, we've talked about this way too much. Let's just go take a look. Cool. Okay, so this is the bit where it gets a bit dangerous because I'm recording this over WebRTC, and I'm going to do a load of WebRTC calls, and things might go wrong. We'll see. Hopefully it will all turn out well. I've done some practices and it was all fine, but I'm sure everything will be fine. We'll come back. So what have we got here? So we've got all of my GitHub repos on the Nimble Ape organization. And you can see here, we've got Dana, the stream gatekeeper, and it tells you how to install it. We've got, these should be the other way around really. So we've got Dana, TSG, ARI bridge, and this is that ARI bridge that I was talking about. And this is what enables us to do external media, which is pretty damn cool as well. External media we wouldn't be able to do everything that we're doing with speech to text without this ARI app. And then we've got the RTP STT audio server. It's a bit of a mouthful, but essentially this is the repo that receives RTP from Asterisk and then sends it off in the right formats to those 3 providers. You can see here 20 hours ago, less than 24 hours old. Right, let's show you. So that before I get any more of those. Right, let me find, where is my window? Dangerous already. So many windows. There we go. Great. So this is Dana, and so it's built with modern web tech, built with React, Webpack, all the buzzwords, and that's the one that I want. It does funky things like emulates CSS, prefers color scheme light. So my Mac is currently in dark mode, and that's why the background is black. But in Chrome, we can kind of cheat and say we want to see what it looks like when it's in light mode, when the OS isn't in dark mode. And so it automatically kind of flipped to being white, and everything automatically updated to deal with that, which is pretty cool. So I like things in dark mode. So let's go back to spell the American way. Emulate. There we go. Great. So we're in Dana, and it's kind of very, very simple. So we can go in here and we can say, oh, we need to be able to give permission to our mic and to our camera. So let's allow that. Now you can see me up here using the webcam that's already in use. This is where danger comes in. And you can see here a list of devices. So I can change this to use and this should does that update? Why is that not updating? Oh, that's because I'm using audio. Sorry. So that's, I want to use this microphone. For video, I want to use and so this is an application that allows me to have like backgrounds and things. So I'm not going to use that right now, but I'm just using it to show you how you can select your device. And so I can say, I'm going to use Brio. This is where it gets dangerous because Brio is already in use. So we can go back to and you can select your output device. And this all kind of works if the settings are available in the browser. So that's your media settings up here. But you can also set all of your actual connection settings. So you can set all of these using some parameters in the URL. We need to document that in the README very soon, so that you can kind of just send a link to someone. That was added by George at Sangoma. Thank you very much. But you can see here, we're connecting using an extension called WebRTC2 to my Asterisk box, and we're connecting to my MQTT server. I'm not going to press finish because I don't know whether or not that's going to break my demo. Hopefully it will. So I can go in and join my video conference, and this is just a conference bridge in the dial plan, and hopefully you're going to hear I think Alison tell us that we're the only person in the conference. Oh yeah, it's going to check whether or not I look spiffing or not. And so here I can mute myself before I join the room, or I can turn off my video. So yes, I do look spiffing. Just ignore the fact that it isn't showing up. So yes, I do. And that's so now I'm being played hold music because I'm the only person in the conference. So let's go back. You don't need to listen to that. But ultimately, you can see there that that was a conference bridge. And that's what we all expect to hear from a conference bridge inside of Asterisk. I'm not going to show you that. It's just you can go and do it. I want to show you an ARI video conference. So this is going to take a little bit of setup. So let's go back to our terminal. So this is Dana here, and then this is something called ngrok. Ngrok essentially creates a tunnel, and so you can see that I was accessing it using this URL, and it's forwarding it to localhost 3000. So that's this is Dana. These two projects are the ARI bridge and the audio bridge. The speech to text audio bridge. So let's just cancel out of both of these. Make sure that we're in the right. So I've got two laptops right next to me. So hopefully I'm going to make both of them connect. So I've muted the tab in Chrome so that we don't get feedback. And I'm going to do that in the browser in a minute here as well. So you won't be able to hear the other laptops, but you will be able to see transcription coming in from all of them. So let's start up the ARI bridge. So the ARI bridge runs locally to me because it's connecting up to Asterisk up in the cloud. And so I can just do yarn art. And so this is a command in my package.json file. And basically it starts up Node and then pipes it to this thing that makes the logs look pretty for me. You can see it, node index.js, and then we pipe to pnodepretty. And so here are the logs from ARI. So let's start up exactly the same command, start pretty, so this is actually running on the same server as Asterisk. Doesn't have to, it can live elsewhere, but ultimately I've got a NAT on my local network, and trying to get audio through that NAT and everything is just a bit of a pain. So so this is actually running on the same server as Asterisk, but it doesn't have to. Ideally, there's no NAT involved because we use the receiving port as an identifier for who's who. So that's the audio server all started up as well. So let's go back to data. So I'm just going to right click here and I'm going to mute the site so that I don't get horrible feedback. So I'm going to join my ARI video conference. So this is a extension in my dial plan, and it could be anything, but I named it my ARI video conference so that it's very, very, very obvious what's going on here. So I can press join. I'm going to check that I look great, which I do. And there's no one else here, right? You can see that there's no one else here, but we did start up my transcription. So we've got different options here. So this is me turning off my mic. This is me sharing my screen. So if I click on that now, you can see this pop-up appear, and it shows you all of my different monitors. I'm not going to share my screen because there's no point, but you can see that, what's the other thing that I wanted to show? Transcription. So all of this time I've been talking, right? And I already started up my transcription engine. So if I click on this, hopefully you can see that they've all been battling out. And that permission denied is because of the because of me trying to show off screen sharing. But you can see here that we're sending all of this speech off to Azure, Amazon, and Google, and they're all battling out. And you can see that they all do things slightly differently. You can see that Azure kind of hasn't taken a breath. It thinks that I'm talking about with one transcription only, because I haven't stopped talking. Whereas Amazon is a bit more kind of less forgiving, and it sees all of these separate things where I take a pause as a pause. And it's the same with Google. So you can see that's Dan Jenkins. I'm talking an awful lot, but I should be able to, when this catches up, should be able to, I want to go out. Why is that not working? Oh, something's not quite right. Okay, we'll just let Amazon battle it out. We'll just let all of them battle it out. So I've got my other two laptops here, and so I'm going to join from these other laptops, and hopefully so I'm receiving some video over there. Oh, something went wrong. You can see something went wrong. Screen share, stream. It was me pressing the screen share and that broke everything. So let's go back. Yes, I do want to see everything. And you can see some video from one of the other tabs, from one of the other laptops. So we can go up here and you can see that I'm talking in all of these are exactly the same, right? To a degree, all of these, something really isn't. But let's just go back into there. So I'm talking into the mic of all of these, right? And so I'm just seeing whether or not, yeah, something's not quite right. But you get the gist of it. Pixelbook A, Pixelbook B, and Dan Jenkins. And they're all talking, and and at the moment I'll be sending 9 streams up from my Asterisk server all the way up to Amazon, Azure, and Google. So this is pretty cool. Something's not quite right here. Just ignore that it's not quite working, and I'm going to close down these. Essentially, you can see video. You can see video. I'm just going to close down these other ones, and then I'm just gonna do it. What's interesting is I'm still getting all these messages from a Pixelbook that's closed. So maybe I'm just sending too much data I'm using MQTT as the mechanism to be able to deliver all of those things. And maybe MQTT is a bit history. Let's open that back up. It's a little bit bogged down. So let's just close that window. Damn it. Yeah, you can see there I'm talking into the mic. So it is backed up, and that's probably why I can't close down this window. Oh, there we go. Great. Okay. So something that I didn't show you, obviously, was, I want to reopen my window. No? So anyway, I didn't show you chat, but basically, and obviously I didn't completely show you screen sharing as well, but the functionality is there, and everything goes through Asterisk. Other than MQTT for delivering transcriptions, everything is going through Asterisk. So let's take a so let's take a very quick look, because I don't have too much time, because I want to have time for questions. So if we take a look at these projects, so we've got Dana itself, and this is a standalone project. You don't need the other two at all. You only need if you want to be able to do transcriptions, you need the ARI. If you just want the ARI, but you don't want transcriptions, you don't need the transcription at all. Obviously, there are some dependencies in here to say, right, go connect to MQTT, for example. If you set a URL, then it's going to go talk to MQTT, even if you don't need it. But why would you set a URL if you don't need it? But ultimately, you can go and fork this project and make it your own. So that's really great. So we can go into source, and we can go into components, and then you can see it's kind of laid out really, really kind of simply. That footer that was at the bottom saying made with love by Nimble8. So that's the footer, for example. That page that had my webcam, my selection, my drop-down boxes. That's media settings. And video room. The video room that we were just in is video room. And then all of those videos that got shown are video.js. So it's pretty, I wouldn't say it's simple, because React isn't simple. But ultimately, this is a great start for how to get started writing something modern with Asterisk. So that's Dana. Then we've got the ARI. So this is just Node.js. And so you can see in here, we've got an index.js file, and we're talking to MQTT, for example. And we're going, if we've set the URL in our config file, then we go and connect to it, and we go and do all of the normal ARI type stuff for the bridge. So you can see here we've got a stasis start event, and we go, oh, have we already got this bridge? Does this bridge already exist? Then go get it and use it. Oh, this bridge doesn't exist. So let's go create a new bridge. And so we've got a lib with bridge. So we go create a new bridge. And this bridge has a create function. And so we go off to the ARI. So we create a bridge using the ARI client, and we go create a bridge. We tell it we want video SFU and we want mixing, etc., etc. And so this keeps track of all of the channels that are in that bridge, but it also goes and makes our external media, which is pretty cool. And so this is the bit here, external media options. And so external media res. So this is the bit that actually goes and makes that external media connection. And ultimately, what you can see here, I'm snooping on every single channel individually and attaching that snoop to the external media so that we get this one-to-one relationship and we know exactly what Fred said or Dan said. And then this is the audio server itself. The audio server is pretty complicated for someone like me. I'm not used to dealing with RTP, like pure RTP. I'm very much used to using like streams in a browser. But ultimately, it's laid out pretty simply. So we can go back to index.js, and we can see here that we get an event to tell us, we get an event to tell us when there was a new stream, and we get told that via MQTT, because we're already using MQTT to deliver the transcriptions themselves. So we actually connect that ARI process to this process using MQTT, so that we can say, there's a new stream coming your way, and here's the information about it that you need. And oh, that stream ended. Let's go and clear down everything. And so we get told that we've got a new stream, and then we go and say, right, go look in our config to see whether or not Google's enabled and Azure is enabled, and then we go and create streams going off to them. So create new Azure stream. I'm not going to look at all of them, but you can see here.
Currently in Dover, it's 12 degrees.
Thank you, Google. You can see here that it's pretty simple. We're telling it what language code we want. We go and create a new connector. I'll show you the connector very briefly in a minute. We keep a track of it. And then when that connector emits a message, we then send it over to MQTT. And it's that simple. This is where the complicated bit comes in. But ultimately, that work's already done for you. So we go and create a connector. We go do loads of Azure type stuff. We create a new ID for every single message so that enables us to kind of put it into that UI. That's how we can update each list item in that list as I'm talking. And so we just get the results, and then we emit the message. And the code in index.js is the bit that goes, we've got a message, we're going to send it down to the browser. And that's as simple as it gets. So that's Dana and the two other projects that are kind of tied to it. Right, let's go back. I'm running out of time because I want time for questions. So, right, phew. I mean, how did that all go? I mean, I hope it went well. What do you think? Tell me in a minute. I mean, only future Dan knows. Oh no, that's not true anymore. Hopefully, you all think that went fairly well. So hashtag winning, maybe. Did you like it? Do you think you might use it? If you go and use it, then you can come and sponsor Nimble8 on GitHub. And pretty much all of the money that you give enables us to be able to spend more time writing open source code. And that's pretty much it. That's all I've got time for. Yeah, that pretty much is all I've got time for. So thank you very much, and I hope you get excited about Dana. And hopefully you can do cool stuff with it. Oh, I forgot to show you. So very quickly, there's these other two projects. So Dana's audio server is very much geared towards speech to text, which is useful, great for transcriptions, great for like having this transcription at the end of a meeting, right? and you can even then make that text searchable or whatever. It's great. But these other two projects here might also be very interesting to you. So they're called Asterisk Dialogflow ARI Bridge and Asterisk Dialogflow RTP Audio Server. You can see they're named very, very similarly to Dana. Ultimately, this enables you to have one-to-one bridges with Dialogflow. Dialogflow is a project from Google, and it enables you to make conversational IVRs / whatever using AI / programming / whatever / webhooks. And so Dialogflow is in itself extremely powerful. And up until now, well, up until like almost a year ago, when did we have our first commit to this? So initial commit was back in February. So around Christmas, around January, this project got started, and finally I managed to make it all work on Valentine's Day. I was at another conference. So ultimately, you can create conversational bots / whatever using external media. External media is probably one of the most exciting things in Asterisk, from my perspective, in a very, very long time. Right, that really is all I've got time for. So hopefully, I'm going to see you all in a minute for questions. Press play. Yes, thank you very much for listening, and I'll see you soon.
Dan Jenkins, it's so great to see you again. Thanks for being on our virtual AstriCon. We really appreciate it.
Thank you for having me.
Well, you've had quite a bit of back and forth in the chats, so I'm just going to turn it over to you, and you can elaborate or answer some of those questions. The floor is yours.
Okay, so I'm just going to kind of scroll back. I've answered a load of questions in YouTube, but they're not on the video and everything else, and this will get reposted. So I got asked about bandwidth and how an SFU kind of might be bad for low bandwidth environments. So Asterisk has the ability to be able to set a bandwidth limit on each participant. That's currently static. So you can only say, well, even if I'm in this one-to-one meeting with someone, we're both getting a really poor experience maybe. But if you're in a 40-person conference, then we're all getting decent experience. So it's a kind of like this halfway house at the moment. And then Josh piped in a little bit later to say improvements are coming, hopefully. People said, why am I using SIP messaging instead of MQTT for, say, chat or even WebRTC data channels? It's an Asterisk showcase project. So the ability is there in ConfBridge, for example, to be able to do SIP messaging and for all of that to get pushed out to everyone. So I might not use SIP messaging in production if I was building something like this, but it's a showcase project. It's meant to show off what Asterisk can do. So that's why we included it. In a later version that's on master right now is a load of extra stuff that Asterisk actually sends out, like events. So you get told when someone's speaking, and you get told like people's names. And so now in the master version on GitHub, you can actually get people's names as a tablet. No, I can't remember. Pill. That's what we call it. As a pill at the top of the video, so you can actually see, oh, I'm talking to Josh or I'm talking to George. So that's SIP messaging. Bandwidth. Yes, peer-to-peer. So yeah, I used an example of how just a minute ago, how you might want 2 people at the beginning with good quality video. And so like Jitsi does peer-to-peer for 1-to-1. And then when you get more than 2 people in a conference, it moves over to the SFU. There's actually no reason why you couldn't do that, kind of just very cleverly. Just kind of move people in and out of a conf bridge and have direct media going between participants. What else have we got here? External media. Yes, external media is like the biggest thing for me that's come to Asterisk in the past 10 years, ever since I've been part of the project. I don't think I've been part of the project for 10 years. Yes, no, for someone like me, I'm a web developer who hasn't got a clue how to write good C. So I can't go write a nice module for Asterisk that is able to talk to all of these other services. External media allows me to kind of start spying on channels and getting audio from those channels, and then I can do anything with it. So I can either like send it up to a text-to-speech engine, and there's now 3 or 4 of them in Dana supported. But there's also another project on GitHub for Dialogflow, and Dialogflow is essentially an automated bot, and that project shows off being able to send audio back into Asterisk, whereas all of these all these text-to-speech is purely just sending audio out and getting text back. What else have we got here? I think that's it in terms of what I answered earlier. Let's go back here. So yes, there's a question in Slack was, have I load tested this? So I mean, technically, it's Dana's just a client-side project. If you don't take into consideration the audio bridge stuff, so theoretically it can scale as far as your browser can. Asterisk itself apparently might not do very well with a high number of video people in there. So yes, but if you limit bitrate and everything, it's fine, is what George is saying in Slack. Someone asked the question about if they were building something fresh today, what would they use? Would they use ARI? And the answer to that is it's not as simple as that. So there are some great projects out there, some great companies out there using ARI in production today. And they all end up using something called a ARI proxy, just because of the very nature of how ARI works. So to be able to scale it out, you end up using an ARI proxy, and then you talk to the proxy, not Asterisk and not the ARI directly. And some people like that. I don't. I think it ends up being kind of this middle thing, and I'd much rather us kind of develop this new way of talking to the ARI that's a bit more scalable. But saying that, if you don't need 50 Asterisk boxes or even 5, and you're quite happy with one Asterisk box that's doing an awful lot, then absolutely ARI is the way to go. You write stuff in whatever programming language you want, and you tell Asterisk what you want it to do. It's far more flexible than anything else. I personally hate the dial plan. So ARI is perfect. I just wish it kind of was easier to scale applications out using it, but hopefully that will come at some point. I think that was all of the questions. If someone has any others that I haven't answered, then like shout. But we're on a bit of a delay, so we won't actually get it until we're done. Yes, I think
in the chats.
I think I've answered everything. I think.
Well, if they come up with anything, they can drop it in the Slack channel, because I'm sure you'll be around for a few.
Yes, absolutely.
All right. Thank you so much, Dan. Again, it was a pleasure to see you again.
Thank you for having me.
Bye-bye.
Joining us now, Joran Vengeance, SIPGate VoIP developer.
Hello and welcome to my talk. Today it's a little bit different. As you see on all other talks, we are not in flesh and seeing each other, and I cannot ask questions. I would normally do that. But yeah, these days require different methods. So now it's streaming time. So my talk is about bridging calls using ARI across Asterisk instances. Normally, I would ask how many people of you are using ARI overall, and then count some hands or something like that. Maybe you can put that in the chat so I can read it while this is streamed. But first of all, let me introduce myself a little bit. So my name is Joran Vengeance. Here are some contact information, so you can contact me if you have any questions later on, or you have other questions, just give me a message. I'm working at SIPGate. SIPGate is a VoIP carrier in Germany, and we offer services in Germany and the UK. And we are on the market since 2004 for private customers or residential customers. And since 2008, we are offering services for business customers as well. And since 2013, we became MVNO, so we're offering mobile services, and we have our SIM cards integrated in the virtual PBX we offer. So we are quite around some time, and since 2004 we are using Asterisk, and so we have some legacy with us, and all of what I'm doing at the moment is getting out of this legacy. So what bridge calls? It sounds easy, but it's not that easy if you have the environment we have. So what we are trying to accomplish with that, we are about to build the best VoIP platform ever. I think all of us are saying that, and nobody reaches the best platform, but how we try to at least. So in the past, we are using AMI and fast AGI, but for connecting calls, we are using AMI. But now we are rethinking everything again, and since Asterisk 11 to 16, 18, there are some differences, so we have to rethink everything. So we want to use modern technologies. So ARI comes in quite handy for us. So what's all about that? Yes, it's about bridging calls. And it's not like a normal bridge you would think as resources in the Asterisk, but bridging calls like you would do on a pickup or a conferencing system. So normally you have a normal Alice calls Bob call, and in the middle you have some bridge, and then there is an initial new call which is only due to business logic assigned to one of that call, like pickup. So you press some, or you make a call to *9, for example, for pick up the call, and as it hits the system, it is not visible that this is a pickup call, but only due to you configure this short dial to be a pickup. So it's something like that. And it's not like just an Alice calls Bob, the bridge in the middle bridge type of bridge we want to do. So connecting call A with call B sounds simple, but I can assure you it is not. So using built-in applications from Asterisk is simple. So you could use the app dial or something like that just to have a call. But since we're using different methods and we have some other problems, it's not that simple. We're using ARI in a high-scaled environment, and especially to that, all of the Asterisks are remote controlled. So it's not the usual way of doing things. So why want we do that? Why do we want to use ARI in the first place? The answer of that for us is scaling. So it's that simple. Scaling brings some problems you wouldn't have on different conditions. In our thinking, so we thought about how do we scale up our platform for fitting all these customers we have, and we came up with 2 ways of scaling. So there might be more, but we thought about 2, and these 2 are the first one. It's quite simple. You bring up an instance for each customer. So it looks something like that. You have an SBC in front. In our case, it would be Kamailio, because we use Kamailio very heavily in our systems, and then you have an Asterisk instance for each and every call. And all calls routed to and from the customer is routed through this Asterisk instance, and everything is good. But there are some drawbacks. First of all, there is a limit of the size of the customer itself. So you're running this Asterisk instance on a special machine or on a virtual machine or on a Docker instance or whatever. And this instance you're running this in is limiting the size of the customer and the amount of calls a customer could do. Then as well, the most challenging one normally is a single point of failure. So you have one Asterisk instance. As soon as this crashes, all calls of this one customer are dropped. And I can assure you, your customer will call you and say, okay, this is not good, and I lost all my calls, and this was expensive for me, and so on. You know, all know about these complaints. And then depending on how many customers you have, orchestrating instances with a lot of customers might be challenging. So let's think about, you have, I don't know, 10,000 customers. And all of these 10,000 customers have an own Asterisk instance, and you have to orchestrate all of these. Then you have to really think about where to put all these configs to. So we put that option beside, and we thought about, okay, let's think a step further, and we came up with spreading all calls randomly across all instances we have. So something like that. We have still a Kamailio in front as a session border controller, and we use a dispatcher set or dispatcher module in the Kamailio to randomly route all calls to the Asterisk instances. So no matter which customer is calling or is called, we just pick any of those Asterisk instances and forward the call to. So we eliminate some problems with that, but we create some new. So what we achieve with that is we have no single point of failure. So if one Asterisk crashes, yes, there are same amount of calls probably involved as we had if we have a special Asterisk for this single customer. But since the customer don't know each other and they don't know, okay, there were 200 dropped calls, for example, they just notice one dropped call out of all the calls they have in the company. So the amount or the impact for the single customer is way less than it would be if all calls are routed through. Then you could have mixed hardware types. So you can have very old PCs, could have very new powerful machines. You could use various types of container solutions. You could have it on-site or on-premise, or on-site, on-premise, on remote or whatever. It's up on you want to have, and you can mix all that like you want. And then you could do something like rolling deployments. So you can drain an Asterisk instance in the dispatcher set, or you can set it to inactive. And then all new calls are routed to other instances. And this one single node is running empty till it's empty. And then you can install new software. You can make an update of the operation system. You can update the Asterisk. You can do whatever you want, because there's no call on it. You don't lose something if you reboot the system or something. And then in theory, there is no limit in the customer size itself. So for sure, you have problems with how do you configure such a big customer, or hopefully the customer does it by itself. But in general, there is no reason that there is a limit from the telco perspective. Okay, then where's the problem? So in our case, we came up with two major problems we need to face. This is we need to know all the calls, and we have to connect all these calls. So why do I say knowing all the calls? I know all the calls, but in a different way. So let's, for example, take the app queue in the Asterisk. So the app queue is agent routing system for in this case. So a call comes in, and this call is routed to an agent according to its position in the queue. But you have to know the position in the queue, and you have to know which calls are ongoing and which not. So this is quite simple. If you have only one asterisk, you just use the Q app and everything's fine, and you don't have to configure anything else, just the Q app. So two calls coming in on one asterisk instance, and this is routed. One of those is routed to the agent, and the other one is getting some announcement or getting some music and hold, whatever. But it's not forwarded to the agent because you know the agent is busy. But now, if you have multiple asterisk instances, it might be that you have two incoming calls, one on instance 1 and the other one on instance 2. And then you have to know which is the first, or if it's already established, how do you do that? So this is what I mean with knowing calls. You have to know there is a call ongoing, and you don't know that because you have different systems serving this call. And then it's a long time ago, I have been on an AstriCon watching my nearly first talk for ARI, and the clever guy in front says something like, so it's not a quote, but it's the meaning was, if there is no application, if no application solves your problem, build your own application. So there we go. We don't have an application solving my problem because all these built-in applications are designed to run on this machine locally. So what we did is we created a Q app, which is serving with ARI. So we have two asterisk instances connecting to our Q app, and this Q app is controlling the asterisk. Or the asterisk instances in this case. So, but we don't have just two asterisk instances. We have more than 50 asterisk instances in the meantime. And we don't have one Q app because then we would have the single point of failure again. So in logic view, it looks like more like that. So we have an incoming call getting anywhere in different data centers, on different hardware types, on different asterisk instances. And all of these are connected wildly to the controlling instance. We call them call controller. And in this call controller, we have the business logic for the Q app. So what we did there is we tried to make it possible to decouple the call controlling instance from the asterisk. And there I would say invented, but we didn't invent the architecture itself, but we came up with an ARI proxy. There are lots of ARI proxy in between, but we did the first for Kafka and our call controller. So it more looks like that. We have on the left side the phone calling an asterisk instance, speaking SIP. And then we have the RESTful interface from the ARI, so WebSocket and REST interface. Connected to that interface, we have the ARI proxy, and the ARI proxy publish everything we need on Kafka. The call controller, on the other hand, on the far end of the Kafka, consumes out of the Kafka and gets all the messages. In this case, here it's a start, and controlling the asterisk on, for example, playing back something or answer the call or making a new call, whatever, on the same way back. So there's, again, Kafka, ARI proxy, and Asterisk. So this is something we came up with, and I did a talk on that, architecture by itself. If you follow the YouTube link below, you can watch the old AstriCon video on that. And as well, we did that open source, so you could use it. So if you follow the GitHub link, you will find the project, and then you can ask questions there as well, for example. So there is one challenge on that architecture, because Kafka is not a static router. It's more a message queue in our case. So we have to tell the Kafka where to route the message to. And normally we don't care which call controller instance is getting the start, but all of these messages correlating to one call needs to be on the same call controller instance. Therefore, we generate a routing key on the ARI proxy, and all of the messages coming out for this particular call are tagged with this routing key, so we find all the messages at the same spot again. So summing up on this one, we have an ARI proxy generating a routing key. So the routing key is used to correlate all relevant call events, there's only one call controller instance for a call. So all events, doesn't matter if it's a channel event or bridge event or playback event, whatever, it comes to this one call controller instance. So we have this one control of the instance. And then we just have to connect all the call controller instances through a database. And so we have our knowledge about all ongoing calls in the system. So yeah, problem solved. But what about the connecting stuff? Right. There was connecting calls, which was originally the title of the talk. So what I mean, a conference needs to collect all media streams. It doesn't need. It's not enough that that we need all the calls. So in our case, again, calls are hitting different instances because we randomly route them. And the challenge: bring all calls together. And just the knowledge about other calls is not enough. So it's not enough that I know that there is someone else want to speak with me. I need to be connected to these people. So in the normal case, we would have something like that. We have a central Asterisk instance, and we have a couple of phones connecting all of them together using, for example, the AppConf bridge, or we use ARI and use just one bridge to connect them all. So this is not possible if it's not the same Asterisk instance. So it looks more like this. We have two Asterisk instances, and we have two phones connected to its Asterisk instance. And then we have to somehow connect these both calls. And we very shortly thought about the zip method or response 302, so refer. And then we thought, okay, we had to escalate that to the endpoint. And we are not quite sure what our carriers and clients say if we send them a 302, and it was too fuzzy, and there was no good documentation about our carriers or all the phones our customers use. So we dropped that idea and went to, okay, so we need to actually do a call from Asterisk A to Asterisk B. So we put a Camalio in between. This is for a reason I can come to later on. So we do actually a zip call from Asterisk A through the Camalio to Asterisk instance B. So we use the zip proxy to pass all these calls for two reasons, basically. First of all, if we do that and not directly route the calls from Asterisk 1 to Asterisk B, A to B, we don't need to know all the Asterisk instances. So otherwise, we had to fill all the Asterisk instances in the PJ-zipconf just to route the calls there. As well, it's easier on Camalio to duplicate all the traffic to push it into Huma, for example. So our customer care could easily see, okay, there was a connecting call between these two Asterisk instances without having anything installed on the Asterisk itself. And to do so, we provide the routing information we want to have, or the routing target we want to have through a zip header to the Camalio, so we don't have to handle with difficult dial strings whatsoever. We just do a basic call or simple call, in this case, to the Camalio, and Camalio takes the zip header with the destination and put that as next hop and forward the call. Finished. But there are some more things we need to do. So we have an idea how to actually route the calls, but how do we connect these calls? Let's again take conference as an example for this. So we first have to identify this as a conference call and not a queue call or a simple call to that person, whatever. Then we have to check for an existing conference, so we know where the conference is served at the moment. And if there is none, we have to create a new one, or if there is one, we have to bridge these calls. So let's start with identifying a conference call. So this is very easy with us. We identify a conference or these kind of calls by the phone number or the DID. This is very common in Europe because we have enough numbers. So we say our customers, okay, you want to have a conference room, just put it a number there and everything's fine. So there's no need for having call through number and then ask for conference room or whatever. We can just give it a DID. This information is stored globally in a database. So back to our drawing, we have this start coming into our call controller, and we ask the database, is this number a conference call or conference number? And in our case, it should say us, yes, this should be a conference call. So now we have to check if there is already an existing conference on that. So to do that, we have surely to store the data if we already created a conference on this on startup of the conference. So again, this is a database which needs to be globally read and writable. And so we put in there our conference DID as identifier for this ongoing conference, so it's easily to search for in the database. And the serving Asterisk instance and the routing key as value for this. So it might look like something like that. It's a German number here in Düsseldorf, assigned to an Asterisk instance running on 1, 2, 3, 4. In this case, it's an IP address, but could be a DNS name or whatever. And the routing key. So we ask if there is a conference ongoing. We ask that with the DID, and in our case, because we want to create now one new, there is nothing in the database, so we know there is none. So coming to our last challenge, I would say, create a new conference or bridge the calls. Creating a new conference, it's quite easy. We just have to add the call to a conference. But first, we need to write the data in the database. So in the case, we know, okay, we have the first call of this conference. We insert this set of data, which contains the DID, the serving Asterisk instance, and the routing key into the database. From there, it's basically what you want to have on startup of a conference call. In our case, we kept it simple for demonstration here. So we create a bridge in the Asterisk, in this case, a holding bridge. We start music on hold and we add the channel to the bridge and then simply wait for the next call to arrive. So within the Asterisk, from perspective of which resources do we have, it's quite simple. We have a zip channel, we have a bridge, and we have a playback. So that's it. So about adding the next call to the conference, this is quite more complex than just creating the first bridge. So we have to get the data of an existing conference. We have to create a channel and a bridge to the Asterisk instance serving the conference. And we have to add the routing key we get from the database to the channel as a header, so we can use it on the destination machine. So what we do is, first we ask the database, is there an ongoing conference for this DID? And in our case, it is, because it's a second call. And we get the data set back of the serving Asterisk instance and the routing key. From there, we simply control the Asterisk, in this case, the Asterisk B, to place a call through the Kamailio proxy to the Asterisk A, and we add these data, which contains the serving Asterisk instance for the Kamailio and the routing key for later. In this case, the Asterisk A is getting a new zip channel and generating out of that a start. And here we provide the routing key right from the start to the ARI proxy. And now the ARI proxy knows, okay, if this routing key is provided, I just have to add that to all the messages coming out of that Asterisk for this channel ID, for example. So the start of the second or third or fourth calls, whatever, hitting the same call controller instance as the first one. And from there, it's quite easy. We have, the routing key is used for routing in the Kafka. I already said that. And from there, it's quite easy. We have to add the second channel to the bridge. We have to stop the music on hold and set the bridge type to mixing. So then it looks something like that. So we have 2 zip channels connecting to one bridge, and we have basically the start of our conference. For the user, this is a speech pathway. So we have, in this case, 3 zip channels connecting these 2 asterisks and the phones together. This second call is a very simple call containing just 2 zip channels and a bridge. And all we have to do in the call controller is forwarding states. So we don't have any business logic in there, just forwarding states. The business logic is only in the upper call, so in the call originally serving the first call or now serving all the calls. Here we have the one place where all the information come together about all the channels in the conference. So we can provide a web page where we have, I don't know, overview about all connecting clients, how long these conferences ongoing, something like that, for example. This is the only place we have to handle the conference. And it's not spread across all Asterisk instances. So this is cool so far, but there are some problems. First of which, we have possible race conditions. And then we have a big question, what if we have initial calls on the same Asterisk instance, or initial call is on the same Asterisk instance. So first, the race condition. So it's possible that 2 calls hitting 2 Asterisk instances at the very same time, and both a call controller asks the same time, is there a conference ongoing, and the Asterisk doesn't know about each other. So it returns no, there is no conference ongoing for both of them. So we need to have an ACID compliant database storing all this data, but only the consistency is important here. So the second, because database there is one first and one second, the second call must get a rollback on the insert of the information, since then there is already one going. And then we have to catch that in our business logic and say, okay, if I get a rollback, there must be something ongoing in the meantime. And then I select again on the DID and get my conference call back. And then I just have another call for this. The other problem is initial calls on the same Asterisk instance. So what we came up there, or what is best practice of that, is using local channels for that. So in an Asterisk view is the call with the blue round of it is the second call in this case. And so what we want to do is we want to bridge that with the first call. If we would do a zip channel from that Asterisk 2 itself, we would get back a loop detected because there's a loop. So instead, what we do is we just check if the Asterisk instance are the same and then use local channel instead. This is also good for Asterisk performance in this case, and we don't have to have it all through the network. So the benefits for us in this case is it's very easy to orchestrate for us because all the call controlling instances exactly do all the same. There's only one instance controlling the conference and could supply any information for a web page or whatever. And all other calls are very, I would say, stupid or dumb calls, just handle a simple call and forward states. So if we have a conference with 4 participants, these call controller instances or these correlating call controller instances would handle a simple call, just forwarding states, and only there we would have a conference control. So if I want to drop a person or an agent, whatever, I can just say this one conference call, okay, drop this channel or kill it or whatever, or mute it, or you name it. So this is cool for us. And finally, we came to conclusion it's a lot added complexity to our setup. We know that, and it's all about getting business logic out of the Asterisk and use the Asterisk only for speech things and zip things, and not for all the knowledge you have to have about the business logic. And therefore, we get the knowledge about all calls out of the Asterisk, because they are widespread on all Asterisk instances. And we have the flexibility to connect all calls and call types together, and any moment of the call might be on the beginning, might be at the end, might be somewhere in the middle. We don't care. We have all these flexibility, so we have a full feature set of a business logic outside of the Asterisk. With that said, I'm finally finished with my talk. So I'm now ready to answer all your questions. Join me in the chat or poke me later on Twitter or LinkedIn or whatever you want. So stay safe and see you soon.
Hello, Joran. It's always great to have you at AstriCon. Thanks for being with us again.
Thank you.
So you've had some lively discussion on the chat. So I'll turn it over to you.
Yeah, thank you for having me again. And yeah, we had some discussion on the chat. So I nearly answered all the questions raising up so far, but I still repeat them. So the first question I got was, do you ever use Asterisk as relay nodes in edge of your network? No, we don't. We think Kamailio is the better choice for this. So we have an Kamailio SBC in front of every network edge. So Asterisk is good and safe in the back. I hope this answers the question. Next one. There is just an instance of the Q app. I would say not really, because we don't have special app names just for the queue. If the call is handled as a queue or as a conference or something else, is to the business logic. So we just hand over. There is a new call, and you have to figure out what the call is supposed to be. If it's in just a to call or a conference call or a queue call or whatever, and then do the magic there. So the Asterisk doesn't know about anything about business logic. So there are several instances of this call controller serving the calls. Next one. Is the call controller distributed? Of course it is. We have several call controllers running up and running in each and every data center. And all of them subscribe to Kafka. And that's basically it. So yeah, we have a distributed system there, and it's restart safe, so we can deploy new configurations or new code just on the go during the day, and no customer hopefully ever noticed anything about that. Then the next question, what's the latency sending packets back and forth between Kamailio Asterisk and the call controllers? So we made some measurements a long time ago, I think 2 years ago, when we firstly came up with a call controller and ARI proxy. And one cycle, so we had the playback of the monkeys. So it was from the start to the command of answer the channel. It took 30 milliseconds to be processed. Where 10 milliseconds goes to the Kafka and 10 milliseconds to our call controller. I think this is good enough, so it could be better, and I believe the app answer is much faster in that, but we take this 30 milliseconds. Next question. Also, have you tested having these 3 or 4 servers in the same data center and or different data center? No, we try, because of many learnings in the past, to keep all the traffic we have in one data center. So as well as the traffic from the ARI proxy, which is running locally on the machines, towards the Kafka. And the Kafka, we have in each data center an own Kafka instance or Kafka cluster. And the call controllers are distributed on all data center, and the call controller subscribe to the same data center. So we try to avoid data center crossover traffic just because of latency and firewall issues and things we don't know yet. Hope this is answered. Next question, are you using ARI proxy in production? Yes, we do, but just for a very little amount of calls just yet, because we are still in a very early development phase, and the most of our calls just passing fast AGI, AMI, and dial-plan, lots of dial-plan, unfortunately. Next, did you also manage to solve stuff like agent penalties, blah, blah, blah? I can skip that. No, unfortunately not, because we are very early and we haven't done very much development for Q. It was more or less just a sample to show you the knowledge of calls is important in ARI, just to have this different kinds of calls running back and forth. Next one, what is the feedback for ARI proxy written by Sean? Have you given it a try yourself? Yes, we did in the very, very early phase of our development. We tried the ARI proxy written in Go, and we consulted Dan Jenkins. He was in our office and had a good meal and a very good day, I hope. So we gave it a try, and at the end, we decided not against this Go ARI proxy, but against rabbits or nuts in fortune of Kafka, because we know Kafka and we have another Kafka instance for our business logic. So it's more a decision for Kafka itself and not against these other ARI stuff, ARI proxy stuff. Next up, we have in, I think this is all I catched in during the conversation, during the talk. Let's see if there are any left. There's one. Hi, Aaron, what do you do when you exceed capacity of one Asterisk server to be able to be a single conference? We haven't came up with this answer yet. So it would be possible to use all the other instances on the other machines to just not concentrate the entire conference on one machine. But I think a conference with 2,000 participants is a nightmare to be in there, just if you're muted and just hearing some I don't know, radio or whatever. But maybe this isn't the use case for a conference. So no, we haven't, and I doubt that we ever came in this situation. Well, I think that's all. Julie, do you have some more?
Did you see the one, how are you managing call transfers between extensions registered on different Asterisk boxes? Are we trying to skip that one?
No, I didn't, but I didn't see that. And the agents or the telephones are registering towards an Kamailio with the location module, so the registration does not go to the Asterisk itself. The Asterisk itself is just more or less a media relay for that, and doing all the business technology we have. And so far, we haven't came up with a good idea in this case. So 2 days ago on AstriDevCon, I brought up this question, and we'll see where it goes. And as soon as we have an answer on that, I will give it to the community.
Perfect. Well, thanks again for joining us. And I just want to remind everyone that the open source lounges will be open, and you can find the locations for each of those lounges in the schedule below. So go join one and have fun, and we'll see you this afternoon. Thanks again.
Yeah, thanks you. Bye.
Matt Brooks, Senior Software Engineer at Sangoma Technologies.
Hello, I'd like to thank everybody who is joining me on my presentation on FreePBDX performance profiling with Xdebug and WebGrind. My name is Matthew Brooks. I'm a Senior Software Engineer here at Sangoma. I've been working with Sangoma, I guess, for quite a long time if you consider the acquisition of Digium. I actually started at Digium in 2005, and I've just been with the company ever since through the acquisition and everything. So for this presentation, we'll basically go over some of the various debug tools that you can find in FreePBX that can assist with performance tuning, an overview of Xdebug and WebGrind and kind of what they do. We'll go over how to performance profile the FreePBX GUI and how to performance profile AGI scripts. So I kind of start with the initial problem. So what happened was we got an issue that was reported to us that the IVR page in the GUI took a really long time to load. And actually I've got it set up here. Let me go back to the beginning. So if we go to the IVR application and we click on this Add IVR button, you can kind of see that it just takes a very, very long time for this page to pull up. And the customer was actually seeing this take about 1 to 2 minutes for it to load. I've kind of loaded some fake data in here, so it like isn't as bad as the customer was seeing, but it's still pretty bad, and you can kind of tell that it's like just going slow. And so the thing was like we're trying to figure out how do we find out how do we figure out like what is making this page slow. And so some of the things we first start doing is the typical debugging from the CLI. So what we do is we log into the CLI and we run FW console debug. And if you've never run this before, it kind of just gives you a whole bunch of error, like any error message or anything like that when you're loading a page or script. And so what I'm going to do is I'm going to reload it, and you can see all of these functions and warning messages and error messages. And what we were trying to do is just look for a clue of like what could this possibly, what could possibly, is there something that's showing us that this thing is slow? And we didn't really get much information on this. It's a lot of deprecated function errors, but nothing really saying, hey, this is slow. And so the next part of our troubleshooting is we basically try to enable this thing called SQL debug log. And this is kind of a tool that's cool that comes with FreePBX. I don't think a lot of people know about it. But what you can do is you can go and edit like the Etsy freepbx.conf. And right up here, you can define this log prepare as true. And when this is enabled, what it will do is it will log everything to this performance log right here. And so let me see if this, and so basically what we can do is, you can kind of see some queries already starting, but we'll refresh this again. And so what we're gonna do is watch this, and you can kind of see that like, here's all these, it's basically executing a ton of queries. And we can kind of see that it's, since this is happening in real time, it's taking a long time to do these queues. Like it looks like queues config is what it's querying. It's just taking forever for it to like get through it. Usually when you see this kind of stuff, you just see it just scroll by and then it's immediate. But this kind of gives us a clue that like something may be happening with the queues module. The unfortunate thing is like, okay, so we have these SQL queries that are executing, but it doesn't really tell us like, what in this code is slowing this down. We could, try to search for these queries, but more than likely it's not going to really tell us like what exactly is happening. And so basically, comment this out real quick. So basically, what we started doing is we came in here and so basically we start specifically, so these are the problems. Basically, several queries related to queues, and this all prove the queues are calling slowness, and hard to identify a specific place in the code is problematic. So basically what we did was we looked around and we found, for some tools that can help us with debugging or, performance profiling or whatever with these kind of issues. And we came across something called Xdebug. And what Xdebug is it's an extension for PHP to assist with debugging and development. It basically contains a lot of tools. It's actually an extremely useful extension if you're doing development. And, if you do PHP development, it's definitely one of those tools that you just need to learn. Just about every IDE from like Xcode to Vim supports it and you can do all sorts of stuff like single step debugging, which you can actually step through a problem. If you can go put little breakpoints in the code and then actually step through it. And then it can do stack traces for notices, warnings, errors, and exceptions. But the thing that we're really interested in that it does right now is this thing called profiling. And so it has like this built-in profiler that lets us basically take a snapshot of all the functions and stuff that have run during the execution of this code. And then we can go and look back and say, and basically what it is for each function, it actually times how long it was taking to execute and stuff like that. And then we can go look and see, where are we spending our time executing. And basically, Xdebug really doesn't give you anything that's like I mean, if you want to read the output, you could probably read it, but it's pretty much just like raw data. And so to read the data, there's an additional tool that we use called WebGrind that basically we can take the data that comes out of Xdebug, and then it presents it to us in a way that is easy to read and understand. So basically, how do you install it? So actually, let me go back. So basically, to install it, it's pretty simple. You just have to kind of know you need to install the pickle Xdebug module for PHP. And so in the FreePBX distro, we just basically run the yum install. It looks like it's already installed. And then we will edit this debug thing. And so the main thing we want to make sure is we'll just copy, basically you can just copy it from, like, basically these are the things that we want to enable. But the main things that we want to do is, you obviously want the extension pointed to Xdebug. You want to, so we have this profiler, but we don't want to enable it. And the reason, and this is kind of like an interesting thing, we want to have this thing disabled by default, and instead of because when you run profiling against a script, it's very resource intensive because it's actually, like I said, it's recording every single execution path that's happening and writing it to a file. And so when we're not wanting to use it, we just need to make sure it's disabled. So we're going to disable it by default. We are, however, going to enable our trigger. And what the trigger does is it's basically a query string that we can pass to the script that will enable the profiler based on, whenever you include that query string. This other thing, the profiler output name, this is just the name of the file. You can really name it whatever you want. And in this case, we're just going with generic Xdebug out. We could say FreePBX, PHP script X, whatever. It doesn't really matter. The %T is a timestamp. So for each one that is generated, it'll get a unique timestamp of when it was run. And this final one is kind of important, where we have the Xdebug profiler output directory. Because we use not all the usage of PHP and FreePBX is through Apache. The temp directory sometimes isn't consistent, and so the /temp, like the main /temp. So in order to kind of work around like some of the it's not really, I guess it's like I would say it's done this way for security reasons. Like you don't want any other scripts being able to access the temp files that are generated from other scripts when you're running in a shared like web hosting environment. So by default, PHP and will create a unique temp directory that the others can't really access, and unless you know the full path, you can't really get to it. And so what we're going to do here is we're actually going to use the one that's inside of Asterisk that we can control, and then this way it allows us to keep all of the X profiler debug stuff in one place. And so we've just chose varspool asterisk temp because we can write to this directory from PHP, and it's going to not be in a different directory. It's always going to be in that same spot. And this is kind of important when you're testing AGI scripts and stuff like that. So there we go. The other thing you're going to need to do is after you load this extension, you're going to have to restart Apache. If you don't, it won't like show up. You can also test to see if the extension is loaded by like if you have like a test script, just go PHP info, and then you can just search for xdebug. And you can kind of, let's see, you can see that it is loaded right here. So let's see, let me go ahead and exit out of that. So the next thing we're going to do is we're going to install WebGrind, and so it's got its own requirements as well. So let's go ahead and install them. Okay, it looks like it's already installed. We can CD to the bar HTML. Let's see if I wonder. Yeah, I've already got it in there. And basically, you're gonna just git clone it. I'm just gonna remove this. I don't know why I left it in there. All right. So basically, you just clone it from Git and into the where are we? Into the var www.html directory, and you're good to go. The other thing to note is that Python 3 is not linked by default, so you do have to come in here and it's already in there. You do have to come in here and basically execute this to link it. I think this is just a bug with the FreePBX distro or SMG7, but you do have to link Python 3 to Python 3.6. And then that should be it. That's all you have to do to install Xdebug and WebGrind. So how we go and enable it, and let me come back to this IVR page, is actually I was in the right spot. So how we do this is in, so while we're in the URL of whatever we're executing in this, we basically need to add xdebug profile equal 1. And you can also add this as like a form element. So you can just modify the form and add this as like a form if you're trying to debug a post. But since this is just a Git, we're just going to add xdebug profile 1, and this basically tells xdebug to go ahead and enable itself and then start profiling. And so let me go ahead and copy this so you can kind of see it. So basically, come back to the URL that we're having problems with and just add it like that, and then submit it. Now, so FreePBX we do a lot of things inside of FreePBX to protect you from potential security breaches. We got a lot of stuff that is, trying to do the right thing. In this case, it's basically detecting something that's not normal, and it's basically saying, did you mean to do this? And so it's okay for us to go ahead and click on this because we expected to do this. And so now it's going to run it as normal after you click that link. And so while it's doing this, it takes a lot longer. I don't know if you noticed, like, to go profile this, but it takes quite a bit of time to go write it. All right, and so now the profiling has been completed. So now what we can do is we can open a web browser and go to our server. I think this is running in 2001, and WebGrind, and you can kind of see a list of all of the files that have been generated. Usually the newest is the one on top, so we can go ahead and run this, and we'll see. Let's go ahead and update it. And this does take a while for it to like load for the first time. All right, so it's done. Usually when it comes in, I think for the first time you do this, it's usually like this. I think it's like alphabetical order or something. So one of the things you're going to want to do, basically what it's done is it's gone through all the data, and it's saying here's all the functions that have been called. Here's how many times it was executed or called. Here's the self-cost, how long each one of them cost to execute, and then the total inclusive cost. And so the total inclusive cost is basically like these two numbers just added up, I believe, or multiplied. So for it to really be meaningful to us, we kind of want to look at total inclusive cost. And if we sort by the top number, you can kind of get a feel of what has been, what is like taking the most amount of time. And so you can actually click into this thing and drill down and see some of the things that have been running, or you can actually see like this one calls this and stuff like that. But typically what I like to do is there's this graph button that you can click, and what it'll do is actually generate a diagram of all the calls. Like while this is loading, we can kind of look at some of this. So it looks like a lot of this, like this is the function that's taken a long time. It doesn't mean that necessarily this is the problem in the code, but it just basically means that this function was taking a long time. Actually, let me go ahead and pull up. Go ahead and go to my Git. Look for the framework. And then I can see what commits. So it's still doing that. So yeah, so both of these things take a while for them to generate. I wonder if there's some more stuff I can talk about. So let's see. So basically, these are the functions that are. You can actually see that we got queues under here. And let me look at see. I wonder if it tells you like what called from. Yeah, you can see that it's called. Seeing this now, you can kind of see that here's things that are taking a long time. And basically what this means to me, when I'm looking at this chart, is typically when you have these like multiple paths of execution or something like this, usually this is where it is holding up. But it looks like you can kind of see that this thing is happening in queues get, something like that. And so what we did was we actually looked at the code. And I'm trying to remember where it is. There it is. It's probably this one right here. And this is the actual patch, I believe. We actually looked at it. Is this the patch? Actually, let me just go to the. What did I do? That's not what I wanted. I didn't even know that existed as a button. So what? Let me do a unified div so it just is easier to read. So what we did was we looked at the code that's basically here, and deep down inside, what's happening is when this get destination info by module is called, it basically does a call out to Asterisk. And if you look at this right here, you can kind of see that get queues does a database show. So now we're parsing, we're basically calling AGI at this point. And so AGI is just notorious. You know, whenever you try to query the AGI database, it's just notoriously slow. And so this to me is an indication of like, well, this is probably a bad thing. But when we really dug down in this thing, we discovered that we're really not using this. We're not really using this edit URL anywhere, or we are, but when we dug down into it, it's basically the same thing every single time. And so I think there's another commit on the queues. So basically what we did was we just, let me see if I can find it. So let's see, this was on release 15. Yeah, so this is where we're actually optimizing it. So basically what we did, what we noticed is the same URL was returned every single time. And so what we ended up doing was basically saying, well, since it's the same URL and we know it's always going to be the same URL, let's just return it instead of having to look it up. Because basically the only thing that basically the only thing it was doing, the only reason why it was hitting Asterisk was to see if the queue actually existed. And really, I mean, if it's in the database, we kind of assume that it's already there. So there's not really a point of hitting it. But we still need this linked URL. And so what we did was we just said, okay, well, for every single result, we'll just return it instead of it pulling it down from it. And I'm trying to find an example of where it was actually generating the config. Yeah, so you can see that this is where it was doing. So here's the queues get test info. And so we were calling this every single time. And then this would go connect to Asterisk and then see if it existed, and then it would return it. So we're just going to assume, basically what we're going to do is we're just going to assume that it already exists, and so you have a database entry for it. And there's no reason for us to verify again that it exists, and just we're going to return it. And basically what this did was it basically allows it to speed it up like tremendously. All right, so what we're going to do now is we're going to install the updated versions of framework and queues that applies our fixes. And so basically we'll just do an fw console ma download install, and then tag 15.0.16.69. And so this will man, what did I do? Framework. So then this lets us, so now we're just downloading this to install like the one with the changes, the performance fixes. And we'll do the same thing with queues, which is version 15.0.21, I believe. And then we'll do the same thing with the queues module 15.0.21. All right, so now that we've updated everything, we'll go back to our PBX and we'll see how fast this makes it. So now when we click on the add IVR, you can see that it happened really quick. It seemed like it was a lot faster. Let's see how fast. Looks like now it's doing it in 1 second, which is like a tremendous improvement. So once again, we can come back. Let's see and do the let's see, what was it called? So once again, we can come back here and add the xdebug profile equal 1. Click on that and profile it. And that was, you can, and then we'll go back to, we'll open a new window this time. Let's see. So this would be localhost WebGrind or /GrowthGrind. We've got a newer one. You can see that it's a lot smaller of a file. It went down from 96 megabytes to 11, which is a good thing. Anytime you're cutting out operations, there's less things for it to write, and so therefore the file is much smaller. So, and you can see that took a lot less time to generate versus like the other time. I'm trying to like see, you can see that Q's is no longer in red basically. So that's kind of a good sign. But it looks like we still have some other things that are, it looks like we have a whole new set of things that are causing it to be slow. And so that's kind of a good sign. When I pull up and so now I'm going to pull up the updated view right here, or the updated graph. And you can see now that, I mean, it's changed completely from what it was. Before we were seeing, it was like a slowdown in get destination. I think it was like with get all, and then that, and then now if I search for get all, I'm not even sure it shows up. So a completely different set of things now show up. And so basically what we've done now is we've optimized this to the point where it's not like the tools, the WebGrind tool is not picking it up as even a concern. So basically what you want to do when you're doing this stuff is when you're optimizing code, you want to fix the biggest performance issue you can find. In this case, it had to do with the queues being called multiple times. And then you want to iterate to see the changes, are acceptable. Once it starts loading within the accepted time frame, in this case, we got it down from like a minute to about 5 seconds. Then you're pretty much looking good time. So how do you know when to stop optimizing? Well, the simple answer is when the app now responds in an expected time frame is when you want to stop. The thing that you want to avoid, more or less, is that yes, the code is fully optimized now and is as fast as it can possibly be, but then maintenance becomes kind of painful. So it is kind of a trade-off as far as like how willing you are to make this thing perform versus like versus long-term maintenance of it. In some cases, you don't really have a choice. You just have to like sacrifice maintenance and know that this is going to be a problematic area, and then just deal with it. So in AGI, we basically do something similar. The only difference is when we want to enable profiling for AGI, we basically just add -d xdebug.profiler enable to 1 in PHP, and then basically this does the same thing. So I will say that again, here's some of the gotchas for Xdebug. It's best not to enable Xdebug in production, even in disabled mode. It will slow down your system even when it's not running, because it does other things other than that. So it's best just to have that module just completely removed and disabled in production. It's also enabled not to. It's basically don't enable it either. Just even in your dev, don't enable it unless you really need to. If you enable it completely, like say I want to enable the Xdebug for everything, your dev system will just grind to a halt and not work. The other thing is it only profiles PHP code. There's a lot of code inside of FreePBX that isn't PHP. There's JavaScript and there's also C. For those applications, you'll have to, if you're trying to performance profile them, you'll have to look at something else. Like some other tool. I think each platform has their own set of tools that you can use. There's also some shared performance profiling scripts or applications that you can use. Unfortunately, I don't know. I off the top of my head which one that can do them all, and I don't really know if they're really good at at finding stuff specifically inside of PHP or whatever. I just know Xdebug is what's recommended for PHP, and I've had some success with it. I will say AGI scripts by design can have a lot of wait time in them. Sometimes you're waiting on an input or whatever. Take that in consideration when you're looking at the profiling results, because if you're waiting on something, then the functions that are calling that that implement the wait are going to wait as well, and so you may be able to filter them out. I haven't really got that deep into Xdebug, but that's just kind of one of the things that you can do. So if you have performance issues with FreePBX, feel free to report them to our Jira tracker on issues.freepbx.org. And also you can install Xdebug and basically include any of the performance traces that you have generated from Xdebug and include it on the Jira. That'll be actually helpful for us. You can actually send us this file, and then we can read it inside of WebGrind without, WebGrind doesn't have to be installed on the same system for you to see it. And that's pretty much it. Like I said, my name is Matt Brooks. You can email me, mbrooks@sangoa.com if you have any more information, or you can find me on Twitter at @allvmatt. And thank you.
Hello, Matt Brooks. Welcome to AstriCon. It's good to see you.
Hey, yeah. Thanks, everybody. Yeah.
You've been with you've been around since Asterisk started, I think. So
actually knew Mark Spencer before he wrote Asterisk. Me and Mark actually went to college together. Actually how I know him. So I remember when he actually put Asterisk together and from his dorm room. He actually wrote it. He was like starting a business for doing Linux support services, and then he needed a phone system, so he just wrote one. And so I have seen it. I remember him calling me on it for the first day, for when he finally got it working. So that was kind of a neat thing. I haven't been working with the company as long as that. I started. I think he wrote that in 1999, so I started in like 2004. 2005, something like that. It's hard to remember.
We've got a lot of questions and comments coming in, so take it away.
Let's see. I think they had some audio, or not audio. They had some video problems that kind of cut out. I think it did cut out an important piece. I was basically just showing you can drill down from the so if you get a list of all of the things that are each function, how long it's being executed, you can drill down inside each one to see where it's being called from, and that may give you an indication of where it's getting slow. The main thing you want to do is just because something is taking a long time doesn't mean that's necessarily where the problem is. You want to find out, and I don't believe it. I think the graph, it didn't show this. I mean, I think I explained it, but I think it cut it out. But typically when things are like in the 99% percentile, so you have like something that's like 99 and the next one's 95 and the next one's 96, you typically don't have a problem there because the times are so close together. What you're really looking for is something that's, when you start to see something kind of diverge, you have like a 50% and a 50%, and then that's kind of like an indication on the, like, at least from the graph point of view, where the problem is starting to happen. So I think that was kind of an important point that was missed. Let's see. So I think somebody asked us what we use to do development. I personally use VS Code to do development on. Actually, there's like a plugin, SSH plugin, I think, a remote, I don't know what it's exactly called, but I actually have a VM set up with FreePBX, and then I use the SSH plugin in VS Code, and then it connects to, I guess, the file system on the remote VM, and then I'm able to do it. Unfortunately, debugging does work sometimes. Xdebug is a little bit hard to get working in this scenario if you're trying to use it for, I mean, it works fine for performance debugging, but if you're trying to do like traces and stuff like that, it's rather difficult to get working. I've actually hacked a few things together to try to make that a little bit better, but I don't think we have anything really that lets you do the actual debugging remotely in VS Code like I'd want to today. Is kind of a problematic area. Most of the team I believe uses Vim. So and I think JNano. So we use a whole bunch of. I don't think anybody we don't have anything standard like a standard IDE that we use. Let's see. Have we? So this is from Bill. Is that I'm using PHP FPM Nginx because I'm weird, but I haven't given any thought of whether it's fast or slower or neither. I don't even know what the difference is between a PHP FPM and mod PHP. I think PHP FPM is like the fast CGI version of PHP, right? I don't know necessarily if I would. I'm actually surprised that actually works. I would say that if it is the fast, what I'm thinking, the fast stuff. I mean, there's definitely some gotchas there, but I would probably be concerned with global variables instead. I think because I don't think the scripts actually kill. I think it stays open and running or whatever. So I think that I would probably stick with Apache mod PHP just because I think Apache pretty much protects you from a few things. So I don't think we've ever designed it to run on PHP FPM. Is there any more questions, Julie? Do you see?
I'm looking in the Slack channel now to see if we've missed anything there. You caught Bill's question. That was in the Slack. And I think we caught them all on the live stream as well.
Okay.
So Matt will be in the Slack channel, so feel free to hit him up there if you have any additional questions. And other than that, Matt, thanks for being here.
Yeah, thanks for having me. Everybody have a good rest of AstriCon.
Thanks, Matt.
Jose Franco Baquero, founder and CTO of Icono Telecommunications.
Hi, Lauren. Thank you for your kind introduction. I'm glad to be part of this wonderful event. I'm excited to have the opportunity to talk about Asterisk and real-time communications in general. I'm sad also to not be there in person because part of the AstriCon is to share with the people. But given the circumstances, I want to congratulate you and the entire team of Sangoma for the great AstriCon you have organized. Okay, today I want to share some ideas of how could you combine, how could you mix some open source real-time communication tools in order to build not just a call center, but a scale into a multi-channel contact center or even an omni-channel contact center. But who am I? My name is Jose Franco. I'm computer scientist. I'm keen on everything related to Asterisk, Matrix, SIP, and real-time communications in general. I'm a proud father of 3 children. So you can imagine that I haven't had time to get bored in this quarantine. I live in Pereira, which is a Colombian city located in the middle of a region known for growing and producing the majority of Colombian coffee, considered by many as the best coffee in the world. So much of you, I enjoy a really good cup of coffee. I work in Icono Telecomunicaciones, which is a Colombian company that provides real-time communications and contact center services, mostly built in Asterisk. We have been working with Asterisk more than 10 years ago, and we have deployed a lot of range of solutions. First of all, I would like to review the definition of an omni-channel contact center and check the differences between it and a multi-channel solution. In a multi-channel approach, you find a different set of channels that are not integrated together. Then the customer experience could be siloed. In comparison, an omni-channel solution, the channels must be integrated, giving the customer the feeling of being assisted in a unique way, no matter the channel they use. Even though the physical stores have to be integrated in this model. For example, you should be able to buy a product in a website, then you should you could pick the product in a physical store, and then you could receive customer support via chat or via RTC or via phone without having any lack of information problem. Then we can conclude that many of the solutions you find in the market are just multi-channel products or maybe a set of multiple products. And it's not necessarily a bad thing. It's just that maybe the name is just a commercial name. I like to talk about Asterisk and how awesome can it be for developing real-time communication solutions. For me, Asterisk is like an astounding box of Lego, you know, with a lot of tiny parts that you can combine in different ways to assemble a product, a final craft. For example, you could use different models in order to do a PBX solution, or you can use Asterisk as a back-to-back user agent or a gateway between ISDN and SIP. You could develop a call blaster, or you could bring a call center solution. In this way, when you use Asterisk to build a call center, actually you are deploying your vision of how a call center must work. Let's take a look into the capabilities, the features that can be used to build a call center with Asterisk. First of all, the protocol support is outstanding. It's really extend. You can use in a call center, as I said before, as back-to-back user agent, our simple gateway for transcoding. The flexibility of the dial plan is remarkable. The number of applications, functions, variables makes really easy to implement complex scenarios. I don't remember the time I had to say, oh, I can do that to a specific request because of this flexibility. The core of any Asterisk-based call center is, without a doubt, the APPQ. This module enqueue calls and deliver to a group of agents, as all we know. You have several sources of resources to extract data and construct metrics. Qlog for me is one of the most trusted source of information, and we use all the time. And CDR and Channel 11 Logger are really good complement. If you want, you can to use another set of tools compatible with Asterisk. One of the best things about Asterisk, if you want to use it in a call center, are the number of APIs you have. You have AGI, AMI, and recently you have ARI, which is awesome. You can do something to develop real-time supervision. You could build automatic dialers. You can do computer telephone integration. Here, the limit is your imagination. And finally, the built-in features that can be used to provide a call center behavior are not less important. Recordings, transfer, whisper, and barge. It's really, really, really great. In this way, you can find a lot of alternatives that use Asterisk to build a call center. From FreePBX acquired by Sangoma, which can be used in small call centers. Dial, which is the most popular open source contact center in the world. Omnilis, which is a relative new platform developed in South America. The well-known Qmetrics monitoring software for Asterisk. Wasu, a project where you can build your own telecommunications platform. And of course, your own project if the current offer doesn't fix your needs. And if your deployment includes a large amount of agents, maybe hundreds of agents or maybe thousands of calls, you maybe want to consider including your architecture a zip proxy like Camaillio or OpenZips to perform load balancing, high availability, and improve security. On this regard, I highly recommended talks from Fred Posner, who is in this AstriCon 2, and also the Daniel and the guys of the Camaillio project. Other interesting talk is one of the Giovanni Maruselli in FOSDEM 2018 about zip and WebRTC, load balancing and high availability. But okay, we all perfectly know that using Asterisk is possible to build a call center. But what if we include extra functionalities in order to include the features that require omni-channel scenario? Well, I would like to introduce Matrix, which is an impressive project we have been using some months ago, not just in our internal communications, but trying to enhance the products we offer to our customers. But what is Matrix? First of all, Matrix is a standard designed to allow users with accounts at one communication service to communicate with other users in different service provider via online chat, voice over IP, and video telephony. It is maintained by the nonprofit organization matrix.org. They have this manifesto which says that people should have the control over their communications in order to avoid silos. The people should be able to pick freely the way they use their communications, and the people should be able to communicate securely and privately, because this is a basic human right. There are a team which is a set of experts from across the world Matrix community and govern the context and direction of the Matrix specification. I really recommend to take a look in the link below in order to get more information about the foundation's principles. One interesting aspect about Matrix is that its lightweight protocol. It uses just HTTP and JSON as its baseline of transport. For example, here we can see the resource used for a client to obtain a message. The response is really simple. You can understand what is this about. And even more complex messages can be obtained in a similar way. One of the Matrix aims is to make real-time communications work seamlessly between different service providers, just like SMTP, which is an example of a successful federated protocol, meaning that you don't need two users to be hosted in the same server in order to communicate between each other. For example, one user located in one server, in one host, can communicate with anyone regardless of whether they are hosted. Matrix includes end-to-end encryption and routes via double ratchet algorithm. It can ensure that the conversation data on the host is just readable by the room participants. This is a major thing in terms of privacy and security. The protocol also supports voice and video WebRTC calls right out the box. We can agree, obviously, that this is a feature very useful by these days. Finally, I would like to make a reference about who is using Matrix. The KDA community announced plans to adopt Matrix for its internal communications on February 2019. Mozilla also announced that they started to use Matrix on December 2019. And in 2018, the French government announced plans to create their own instant messaging tool called Teachup. And in this July, this year, ConCon was virtual, and they included a live chat to run alongside their stream talks. They use also a new project in this talk. Okay, let's take a look on what we can find in Matrix ecosystems to get some omni-channel features. First of all, there are a lot of servers implementations. Currently, Synapse is the most common server you are going to find in production. It is written in Python, and for the average deployment, the performance is really, really good. This, for example, is the one we are currently using in production. The Android is a second generation matrix home server written in Go. And there are another server that you can try if you want. The number of available clients is just impressive for the different kind of operating system developed in several languages. You can choose a client that fits your needs. Bridging is an important concept in Matrix. It's a type of connection with other platforms used to exchange data. You can see that there are several type of bridge, and currently they have developed a lot of implementations. You can access to bridge for Twitter, Facebook Messenger, WhatsApp, Hangouts, and they are really good. Another great set of tools from Matrix are the different SDKs they provide. You can find in multiple languages. There are SDKs for creating clients, bridges, application services, and handle federation and end-to-end encryption. If you don't want to spend much time diving into the SDKs, you can check the current bots implementation. Maybe something you need is already done. For example, there are bots for GitLab and GitHub for continuous integration. There are bots for integrate with a virtual assistant like Dialogflow. For polling, there are a lot of bots. And finally, the application services can be used to extend the functionality of a home server and customize the behavior according to your needs. A common example of an application service is a bridge. At this point, we can conclude that Matrix is like Asterisk, is another real-time communications Lego. We could use some of the Matrix features to extend the behavior of our current Asterisk call centers. Matrix meets typical contact center chat needs. So let's take a look. Let's review some of the expected chat features in contact centers. For example, single and group chats, the access to history or timeline of the chat, the possibility to share in multimedia information, documents, images, audio, multi-channel support, the possibility of use WebRTC voice and video. You need to provide access using web interfaces and applications, mobile applications. Agent bots or chat bots is also a typical request by these days. And if you integrate a conversation artificial intelligence-driven platform like Dialogflow or Watson Assistant, it could be really great. You need to provide metrics, and maybe you want to introduce some kind of bot capable of distribute chats between agents, something similar to AppQ, but with chats. And sometimes, depending on the needs of of your customer, maybe you need transfer. So keep it in mind. Well, I wanted to tell you how we approached the omnichannel scenario using the above tools. First of all, we used the bridges to connect with different kind of networks. For example, in Colombia, WhatsApp is really used. We have these requests really constantly. So we use the bridges in order to have this feature of connecting with WhatsApp, with Facebook, with Twitter. Then we can use the different libraries in order to have a bot, a chatbot, and you can connect these with, as I said before, with different libraries, different kind of bots. For example, in the left, we have a really simple client to send a message to a matrix run and expect a response. It's really simple, you know, it's just like 20 lines of code. And you can have this kind of behavior, you know, chatbot automatically answer to several requests. You can customize according to your needs. You can use different kind of templates that are already public. You can use it to build complex scenarios, as I said before. For example, an automatic chat distribution who has agents to assign chats. We use different interfaces. This is, for example, an interface. The name is Element, and we provide this for agents, and it's already done. And this is the look the customer has. The communication using WhatsApp, and the agent receives this in Element using Asterisk matrix server. You can perform transfers because you can communicate with bots that add agents to a room, remove an agent from a room. You can even have polls, automatic polls, if you want. Finally, you need to provide metrics. And in Matrix, the database is it's in Postgres, so you can dive in the database and extract some information about the chats. I want to talk also about how we perform the WebRTC and zip integration. There are a lot of possibilities here. For example, you can use Asterisk and JS zip. That's the way as Dana does the work, and Dan is going to explain this in this AstriCon too. Or you can use Camaillio and RTP proxy for doing this work. And I recommend AstriCon talk by Lorenzo Miniero, who talk about how you can combine Asterisk and Janus to perform this task. And we choose Janus for doing this work. Why Janus? Because they provide a simple JSON API, and they have this plugin, this zip gateway plugin and it supports multiple simultaneous calls. It supports transfers, and it's pretty simple. You don't have to worry about the complex things about WebRTC and zip. They do the job really, really well. In summary, I like to think that real-time communication solutions are like making a really good cup of coffee. Depending on your needs or what you want, you can combine different ingredients and obtain something great. And open source tools like Asterisk, Matrix, Janus, Camaillio, and so on are the perfect ingredients for doing really, really cool stuff. So thank you very much. If you want to contact me, don't hesitate in do it. And again, I'm really happy to be here.
Sorry about that. I don't know what happened. We had a little technical glitch there, but we're back, and I think everyone can hear us now.
Okay.
So we didn't have a lot of questions. I just wondered if there was anything you wanted to add from your presentation or say to the group.
Oh, I just want to encourage the people to use Matrix to bring Matrix an opportunity. Is a really good tool. You know, you can replace tools like Slack, and it's pretty cool indeed. We are doing a lot of work trying to introduce Matrix not just for this kind of communications, but using Matrix for contact centers, given the features that this tool has.
All right. Do you see any questions on your side?
There is a question there from Fred Posner. No, we are. Have you looked at using Matrix as the WebRTC client? No, because Janus is pretty good. We have used Janus before, and it integrates pretty well with zip. So it's pretty nice to have Janus. And also, I think that the WebRTC client of Matrix is just that simple, and Janus is really more complex. It can handle more complex scenarios.
Very good. Well, Jose, thank you again for being here and being patient with us during our little technical glitch there. And I want to also apologize to the audience and thank them for being patient with us as well. You take care.
In Slack.
Posner, Kamailio consultant, VoIP engineer, and open source enthusiast.
We're going to talk about using Kamailio and Asterisk to create a secure and scalable solutions. And comma what? All right, so here I've written out how you can pronounce Kamailio, and it's Kamailio. A lot of people also say Kamailio. It's a Hawaiian word that means to communicate. And there you go. So who am I? My name is Fred Posner. You can reach me through qxork.com. I'm on Twitter at Fred Posner. I'm a voice over IP consultant specializing in open source software. I work a lot with Asterisk, Kamailio, and some of the other open source telephony products out there. And I have an amazing wife and a beautiful daughter. And that's the three of us there. I like to ruin the picture by being in it. So today we're going to talk a little bit about what is Kamailio, what's new in Kamailio 5.4, which came out this year, just a little bit ago. Then we'll discuss some common deployment scenarios that you would do with Asterisk, and briefly discuss some examples, as well as how you can get more information to help your deployment. So what is Kamailio? Here's one of the favorite slides that you can see when you're looking at Kamailio. And basically, Kamailio is part of your unified communication platform. Okay, so it's an essential part. It works well with your billing systems. However, it does provide some billing aspects. It works great with your PBX, such as Asterisk. It can integrate with social networking. It can integrate with voicemail and all of this. So it's a central part, kind of an edge router. Kamailio itself is open source. It's an open source SIP server. It's been around for just about 20 years, 19. We just celebrated the 19th birthday. And it's a SIP proxy server, a SIP registration server, SIP location server, a SIP application server, a dispatcher server, which you can use for load balancing. And it's also a SIP WebSocket server. So it can handle WebRTC and all of those things. You'll notice that we use SIP in there a lot. It is an open source SIP server. Sometimes it's easier to think about what isn't Kamailio. And Kamailio, of course, is not a back-to-back user agent. It's not a SIP phone. And although we say it's not a media server, there are some modules that make that a little weird. But in of itself, it's not a media server whatsoever. It can help with proxying media through RTP engine or RTP proxy, or you can just use another endpoint such as Asterisk in there. But of all the things that Kamailio isn't, generally Asterisk covers the rest of them. So hopefully you're already familiar with Asterisk since this is AstriCon. But Asterisk itself is a back-to-back user agent. It's a SIP phone, it's a media server, and so many other different things. Kamailio generally sits in front of Asterisk and helps Asterisk by offloading some of the tasks that Asterisk really just doesn't need to do in a daily function of life. With that, you get some selected benefits. First benefit, of course, is it's open source, and you should be already happy about open source being Asterisk fans. We have great longevity. Right? Again, the project's been around for 19 years now. It can run on a very small footprint. So, you know, hitting 500 calls per second on a Raspberry Pi isn't unheard of. I wouldn't go to production on that, but, you know, you really don't need to break the bank in terms of hardware for benefiting from Kamailio. We interop with a tremendous amount of products out there. Again, we're very SIP oriented, so we can work with most of your other SIP endpoints and carriers and other deployments that are out there. It's extremely fast, and it's also modular, similar to how Asterisk is, and you can gain performance by only running the modules that you need. So Kamailio, like I just said, is modular. So we have the main core SIP server, and then you can load modules as needed. So for example, if you wanted to do some NAT working, and Kama-Ilio is amazingly helpful in terms of NAT traversal and helping you with endpoints that are behind firewalls. So you might want to load some of the NAT modules. You could load the HTable module, which I'll talk about in just a moment. And let's say you need to, connect to Redis or MySQL to gain information about a call. You have those modules that you can also load. If you don't need to, you don't load it. And then that helps Kama-Ilio keep its very small footprint. Kama-Ilio has over 100 different modules available for you. And, it's just phenomenal to work with anything that you would need to do that's SIP oriented. In discussing some of the modules that are available to us, I want to hit my favorite one, which is HTable. And HTable is it's been there since 2010, and it's a hash table. Basically, think of it as an internal caching system. Basically, Redis for Kama-Ilio that's built in. It just stores information in a hash table in shared memory. So it's your custom cache system, and you can also replicate this through what we call a distributed message queue that's built into Kama-Ilio. It's a module, and that allows you to share this information with Kama-Ilio nodes, across your network or across the globe. So when we talk about scaling and growing Asterisk deployments, HTable and DMQ are two key components to that feature. And again, this has been there since 2010. One of the co-founders of Kama-Ilio and our main contributor, Daniel, likes to say that if you're not using hash table, you're probably not doing something correct. So HTable is just phenomenal. I mean, if you think about a great scenario would be running a SQL query. If you're looking up where to send a call, for example, call comes in, you might run a SQL check and go, okay, this did points to this user. You could keep that in memory for 15 minutes, an hour, a day, however you want, and then just automatically know that it's there. Keep it internally in the hash table and not have to do any SQL lookups or anything like that. It's phenomenal. Game changer. Another great module is Chemi. And Chemi is an embedded language interface. There's a great link there, and I'll have my slides available for everyone where you can read about it. Dan Jenkins gave a talk maybe 3 years ago at AstriCon that your next phone developer is a web developer. Chemi is a way to help with that. Kama-Ilio itself uses its own scripting language. It's not really difficult if you're familiar with Perl or C or any of the basic scripting languages. It works in that route. But for some people, I already know Python, I already know Ruby, I already know JavaScript. I just want to write in that language. Not a problem. You can do Lua, you could do Python, any of these work right with Chemi. So we have Python, Lua, JavaScript, Ruby, Squirrel, and you could write the Kama-Ilio routing just in your language and have it work there. And it's phenomenal for those people that already have a staff of, for example, web developers familiar with those types of languages. I'd mentioned just a little bit ago about DMQ, and that's our distributed message queue, and it allows you to replicate data to other Kama-Ilio nodes. That could be on the same LAN, within your WAN, or globally. You could just share it anywhere you want. It's a special way for Kama-Ilio nodes to speak to each other, and that's been within the project since 2010. Another key module that really helps with scaling and growth is Dispatcher, which has been there from the beginning. And this is a SIP load balancer that's very lightweight, stateless, allows you to use a variety of algorithms to determine where you would like to send your traffic. So for example, you could send it based on a weight-based routing. You could do round robin. If you're familiar with, like Asterisk queuing, you could do those same kind of algorithms. You could also do loaded weights so that, for example, if you had one PBX that was a little bit beefier than the others, you could send more traffic there. You could do sequential, or priority-based routing, and you can choose what you would like to do this type of routing on. You could hash over, for example, the number that's being called or the domain. Since we're multi-tenant, you could have, a variety of different domains out there, so that calls that should be on the same system get sent to the same system. So for example, all of your clients in company A, you might want on the same Asterisk box to handle it. Or you might want, for example, a DID for all conferences that are the same conference number going to the same conference server. So however you would like to route upon, and different algorithms, there's well over 10 of them. We just had a new one that came in, which is latency-based dispatching. So you can choose to prioritize the node that is responding with the best latency. So it might not be the node that's physically closest to you. It's the one that is showing you the best latency. And it's just phenomenal. And this helps with both reliability and growth. I had said earlier that we have a new version out, and that is 5.4 that came out this summer. And, we have some great new changes and new modules in there. One of the modules that I'm kind of excited about, and this has been discussed at previous AstriCons, there was Yaron had discussed how they're using Kafka in some of their deployments, and there is now a module that directly integrates with Kafka for Kamailio, and it produces and sends messages to a Kafka server. So it's great for doing CDRs or any kind of logging events or anything you'd like. And we also have a new lighter DLGS module for dialogues that tracks dialogues in a stateless mode. So those are two fun modules. There's two more modules. MQTT is a bidirectional and publish subscribe communication, uses MQTT broker. So that's another type of message queue that's out there, and we can now integrate with that in both a publish and a subscribe mode. And SecSip ID is our Stirk and Shaken implementation, according to those variety of RFCs covering Stir and Shaken. And again, those are open source and new in 5.4, so they're out there now. Some more things that are new in 5.4. We have 5 new modules. We updated 70 modules. There's been more optimizations for Chemi, the embedded language interface, and some core updates as well, and much, much more. We always recommend to people that they run Kamailio in a newer version. We support the last 2. So if you are running Kamailio, we really recommend that you be running 5.3 or 5.4. Most of us are running 5.4 that are active in the project, and it's very stable, great, and we're already at 5.4.1, I believe, as of this discussion. So it's great, and we look forward to hearing your feedback on the deployment. So now let's get into the fun of the matter here, okay? So we have some common deployment scenarios. All right, so the basic, most simplest way of deploying Kamailio would be as a simple edge router, or kind of like as an SBC. And basically you would just have Kamailio in between your Asterisk box and the internet for here as an example, or it could be just on your LAN, but you would have your Asterisk system behind Kamailio, and then Kamailio would then determine who's good and who's bad and allow traffic accordingly. So this is great for security, and this is so if you only had one Asterisk node, you can still really benefit from Kamailio, and just as an edge router. This would work with multiple Asterisk boxes, but even if you just had one, you could use it for security. So the simplest deployment would be a simple edge router. Kamailio has an amazing way of bridging. So some other deployment scenarios, and this is a great one that's kind of really helped with COVID, is as a bridge. So for example, let's say you have Asterisk and you're really ingrained, it's you know, you really don't want to touch it because it's got so many different features on it already, and you really don't want to do many updates, but you need to allow people to remotely connect to your Asterisk from their house, and you want to do it in a secure mode. Asterisk can benefit by having Kamailio act as a bridge. So for example, Kamailio could be set to only accept TLS and connections from the outside. So you're doing SIP over TLS, and then not having to change anything on Asterisk, it could then send that to Asterisk as UDP. So it can act as a TLS to UDP bridge. And in those same aspects, it could also do SRTP to RTP. So on Asterisk, you wouldn't really have to change anything. As far as Asterisk is concerned, the endpoint is local, you know, assuming that you've deployed the Kamailio locally on your LAN. So as far as Asterisk is concerned, there's no NAT, no nothing. It just connects to Kamailio, and then Kamailio then bridges to the endpoints via secure protocols. So TLS, SRTP, that aspect. I love this. I put up a example config as a simple TLS SRTP gateway for your PBX. And so if you do need to allow secure remote workers to your Asterisk or free PBX, please, we'd love for you to help your business stay connected securely. You don't have to just do TLS and UDP. We can bridge anything. So anything that Kamailio can talk, it can talk the other one. It's a great translator. So it could be that you're doing IPv6 to IPv4 or TCP to UDP. So protocol changes, IP changes. You could also do WebRTC to SIP. So if you're running an older version of Asterisk, which of course everybody should be running more stable. There's some great long-term releases out there, LTS releases. But should you not be running one that supports WebRTC or don't choose to run WebRTC on Asterisk, you could use Kamailio as a WebRTC to SIP gateway and just pass on information as needed to Asterisk. So bridging is another great deployment option for Kamailio. As a dispatcher load balancer, this is where Kamailio really starts to even separate itself from some of the SPCs. So you could be running multiple Asterisks behind your internet here. You could have, let's say, one Asterisk that's just for conferencing, one that's for voicemail, you know, or one that's handling sales, one that's handling some other aspects, however you choose to decide it. And Kamailio can sit there and balance the load, as we discussed before, with different types of algorithms and lookups. It can go, okay, this call should go to the first Asterisk, this call should go to the second one. If you're running some sort of high availability, you might have that these are all the same type of Asterisks, and you're just sending calls to the three of them to help you with the amazing call load that you're handling. In which case, dispatcher and load balancer really shines because it handles some fault tolerance. So if one Asterisk fell down, it would then fail over to the other two, and it would just make sure that your calls still get handled by a proper Asterisk, you know, assuming that, you know, they can handle a failover route. So as a dispatcher load balancer, Kamailio just really helps you deploy phenomenally. When you start to look at everything together, this is where we really get into scaling. So when you add your DMQ, for example, and you have multiple Asterisk nodes, and you deploy in multiple regions. So you might have an East Coast and a West Coast if you're in the US. If you're global, you could have one in, you know, the US, one in Europe, however you choose to have it. You could have 3, 4 different comma ilios. They're sharing state. So with this DMQ module, when I decide, okay, well, this asterisk in the West Coast needs to handle this certain call for this DID, regardless of where that call lands. If it landed in the East region, it knows that the asterisk in the West, and it can send it over to there. So by keeping state, by knowing that your customers globally are using X amount of calls or anything like that, you can really help deploy tremendous amount of traffic, and then having those asterisks as you need in each region. And you can put your logic in one node and then have it replicate to all of them. So it facilitates a great way of making sure that logic is global. When you start looking at some of this aspect in a chart, you know, it could be that, you know, I'm taking traffic from one PBX and sending it to another PBX through comma ilio, and comma ilios are talking to each other, and the PBXs can all communicate, and everybody's happy. And it just really allows for a global, highly available global deployment of your communications. And when you start to incorporate other types of bridging, it's just phenomenal. So here in this aspect, you could use, for example, Janus and comma ilio together, handling certain things with internet, and go from there and handle asterisk as needed. When we start talking, I'm going to go back a couple slides just here. When we start talking about load balancing, one of the things I did want to mention is that this also works the other way. If you imagine that the asterisks are your carriers, the same aspect works for you doing outbound calls to your carriers and things like that. So comma ilio is phenomenal at dispatching locally to your asterisk users, as well as externally to your other carriers or wherever you need to send traffic. All right. So now let's talk about some examples. First, I want to talk about a security example. And this is as simple as blocking by user agents. So in comma ilio, we have the great ability of really getting into the details of SIP. So let's say I want to block a user agent. So, you know, SIP vicious or friendly scanner, or, you know, just the VAX SIP user agent. Generally, all those types of user agents are just absolutely bad and should be just ignored. And so I could choose to just ignore it. This example right here will drop traffic. As far as that system is concerned, if it connects to you with that user agent, you're not a phone. You're just not responding. So that's fantastic. You can also add this to HTable. So take that same information. So I've got, okay, I've blocked I've blocked this because it has friendly scanner in it. And now I'm going to set my HTable to a value of 1 for that source IP. And then anytime something from that IP comes in, because I'm now not going to, you know, let him change his user agent or anything like that. Just that's a bad IP. I don't want to take any traffic from it, so I can block it there. And if I added DMQ here, you can do what I like to call the NATO approach. And since I've blocked it on one comma ilio, I can stop it from hitting my entire network, because once I've updated that HTable in one place, I've now updated it in all of my nodes. So HTable is just phenomenal, and it really helps prevent attacks on a global basis. When we talk about dispatching requests, this is an example of how I would dispatch. And again, you can use whatever kind of algorithms you would like. This one is using a round robin. And so what I'm saying is, okay, let me go ahead and send out the traffic to the first node. And that's what it's doing. It's selecting one of my nodes and then sending it out there. Now, the key here is what I've highlighted, which is the failure route. So what that's saying is, if for any reason this my destination traffic fails. So I get a failure, I get a 400, I get a, anything that needs to be handled in a 404, a timeout, anything like that. I want to go to a special failure route where I can then move on to the next node and handle it there. And this is an example there in the dispatching. I'm just going to go, okay, well, here my request wasn't canceled, because if I'm canceling, there's no reason to go to the other one. I never received a response from that node that I sent it to. So let me go ahead and send it to another one. And you can put whatever kind of status checks you want in there. I only want to send it to, let's say, if there's an internal error, an authorization error, because this one carrier always tells me that I haven't paid my bill or something. But I don't want to, let's say, use a 486 or a 404, because I'm just going to end up costing myself a lot of money when the phone is busy. And so then that's a great example of dispatcher routes. Dispatcher also has its own unique fun trick, which is it has a destination down. So if a node that you're monitoring goes down, you can go, okay, let me run some sort of notification. So I could send out an alert, let's say via pager duty. And this way I can use it to monitor the status of my Asterisk nodes. So if I have my Asterisk nodes in dispatcher just to use and monitor uptime, I can then get alerted should one go down and start an incident and start a response to make sure that my Asterisk is rebooted or the problem is fixed or whatever we have there. Why is it, no longer responding to SIP requests? Failure routes are an amazing feature of Kamailio. It's one of the ones that I really love, and that's what really helps you scale. And with the failure routes, you can check for replies, you can check for cancels, you can check for status codes, and you could set them as needed. So I could, again, set one, for example, to use a dispatch failure route. I could have another one use a hard-coded dispatch route. I can set different logic to apply whenever I want. And here's an example of a failure route. And again, I can use any of these failure reply routes, branching and serial all together. So I could go, okay, you know what? I'm calling different phones. Let me go ahead and break down. And now, because of certain status, I don't want to continue my calls to the other phones. I don't want to move on to the next carrier or whatever I want based on whatever status you want. So this is where, and it's one of my favorite things at Asterisk, is that instead of you working towards a big no-name company's logic, you are using your own business logic, your own company's logic, your own personal thoughts on how you can effectively communicate. This is the same way. Your own logic as to what you should do when a call goes wrong, you can then incorporate into Kamailio and move on. And that also works great, again, with the PSTN. When we talked about how small Kamailio is and how fast, one of the things to cover as well is how powerful it is. When we talk about scaling, my rule of thumb was I generally start to really push for putting Kamailio into a network with Asterisk when maybe you have 200 registered users. When you have 400 registered users, at that point, I really insist on putting a Kamailio in there, because Kamailio for 400 users is honestly, very low level. Kamailio can handle hundreds of thousands of users without problem. A single node can handle over 100,000 registrations, because what it does is SIP. And since that's all it's doing, it's not doing the transcoding that, Asterisk does. It's not doing any of those aspects. It can do SIP very well and very efficiently. Excuse me. So it allows Asterisk to do what Asterisk does best, offload some of these activities, such as registration, such as just option pings, things like that. Offload that to Kamailio. Let Kamailio now handle all of your registrations, so that Asterisk can handle the calls and do great media, do conferencing, do mixing, do whatever you would like to do in Asterisk. Let Kamailio handle the boring fun stuff, as I like to call it. And with that, I'm now open for questions. This is generally the best part of the talk, so I tried to leave some room open for questions. I'll be on the YouTube Live, I think we're doing here, and so I look forward to seeing you there. If you would like more information on the project itself, kamailio.org is our website. We have very active mailing lists. We have an IRC channel because, again, we've been around for 19 years. We've also incorporated some matrix rooms. We have some phenomenal presentations, and it doesn't have to be from me. There's a lot of better people out there putting content on Kamailio World's channel. So check us out on YouTube, and on Twitter, we're at Kamailio. And I'm so grateful to be back at AstriCon. I really miss seeing everybody in person. The open source community is extremely important to me. You guys have been with me through major life events. I live in Florida. When there's a hurricane, this community is the first one that reaches out and asks me, am I doing okay? Do I need anything? You guys have been such an important part of my life. I've been able to share so much with you. And you've been so gracious towards my wife and my daughter. And it's just, I really miss seeing you all in person, and I can't wait until the next event. And with that, thank you, and I look forward to your questions.
Hi, Fred. It's good to see you again.
Great to see you.
Another amazing presentation with lots of feedback and comments. So I'm going to turn the floor over to you to answer some of them.
Well, thank you so much. I've been trying to do my best answering as we go along on YouTube Live. It's always a highlight of my year to be at AstriCon. I really miss seeing everyone in person, and you know, it's hard to give a presentation without seeing the looks on people's faces and, you know, knowing if, you know, the few jokes that you've said are actually funny or not. So some of the questions in here has been about SRTP and RTP bridging. And Kamailio can help set up media proxying through RTP engine or RTP proxy. And so you can do you know, a TLS to UDP or SRTP to RTP type of bridging. It's one of my favorite things to do with Kamailio. If you go to GitHub, my GitHub, which is GitHub/Fred Posner, you know, uniquely named there. I have an example configuration in Kamailio that will show how to do SRTP to RTP setup as well as TLS to UDP. There's another question in there about adding SIP headers. And absolutely, you can add and make whatever changes you'd like on SIP headers and send those in as you would wish. So if you wanted to, you know, receive a call from a certain carrier, tag it in Asterisk, so then Asterisk, you know, handles it a certain way, or, you know, based on the caller ID that's coming in, you want to change a caller name or just add an X header or do anything. It's one of the ways that we like to help communicate with Asterisk without having Asterisk to run more you know, lookups or anything like that, that it could just read the SIP headers and act on it. So, you know, that's a great question of can we add SIP headers? And the answer is yes, we can add, remove, manipulate them as wanted. There's a question in there on any books. There are 2 books that I'd recommend. They're both through Asipto. So if you went to asipto.com, there's one that's a free book and one that's a paid book, and they're both by Daniel, and they're excellent Kamailio books. Let's see. And then there are REST services. Kamailio, one of the modules that Kamailio does have is the ability to handle HTTP requests. So you can handle some REST functionality if you'd like, and do send an update to do something within Kamailio. Let's say reload an H table, or change something, or manipulate something. You can do that through API calls if you'd like. And there's some built-in JSON handlers for just running normal Kamailio functions just right out of the box, which is a phenomenal tool. There was a question about cookies. Unfortunately, there's no cookies. I had talked in there about dispatching based on load. So when I say that, it's on call load that Kamailio receives. It's not actually looking at Asterisk and basing a decision, let's say, on if Asterisk has a high CPU or something else like that. You could probably do something to read that through, AMI, or, but that's definitely not something built into Dispatcher. You'd have to, just kind of configure that. Let's see. Okay, I don't know if did anything come in on Slack?
The only one that came in through Slack was the question about how to get started. If there were any books, and you answered that one.
Yep. So there are books in better years. There's been training all around the country. I do recommend going to Kamailio World channel on YouTube, and there are some phenomenal videos there from real amazing people talking about just integrating Kamailio with a variety of different items and different modules within Kamailio. There's been a lot of participation from people with the Asterisk project, which is great. I mean, I think the projects get along really, really well. I know that I've been coming to AstriCon since 2007, and everybody gets along, and I miss it. I definitely miss seeing everybody in person, for sure.
Well, we'll be sure you keep safe and be healthy, and we will definitely look forward to seeing you and everyone else next October in Orlando.
Well, thank you so much. I'm really excited that it's in Orlando because I am based in Florida, of course. So that's great. It gives the excuse maybe for me to bring the wife and baby. There's, this community is fantastic. I love this community, and please, if you have questions, reach out to us. We are friendly. We like to help, and we're always happy to lend a hand. So thank you so much.
Thank you, Fred.
All right, take care.
Hello, and welcome to AstriCon 2020, the 17th annual AstriCon event. Up next, the recipient of the SimCom Award for the nicest guy in VoIP ever. Please welcome Matt Fredrickson, Director of Open Source Development at Sangoma.
Hi, everybody. My name is Matthew Fredrickson, and I am the Director of Open Source Software Development at Sangoma. That's a really big pile of words, but what it means is I have some oversight over the Asterisk project as well as the FreePBX project. And so that's kind of where we're coming from today for my involvement with this talk. So let's talk about what's happened this last year with Asterisk. Asterisk has, the 17 branch has seen 11 bug fix releases. The 16 branch has received 10, and the 13 branch has received 9. And you can see the current most versions of each of those branches. There have been about 1,700 merged code reviews across those branches. And so, that represents, quite a few changes and a lot of effort across the different active branches that we maintain and that we take care of from a project perspective, at least as far as like release branches go. That's separate from like master, which is where new development happens. At the Asterisk community forums, if you're not aware, there are community forums available for Asterisk that live online. I'm a little bit old school and I like mailing lists and things like that, but people do like community forums, and there have been over 9,100 new posts and 750 new contributors this last year. So there's a lot going on on that front. All right, so here's the moment we've all been waiting for. We usually make releases every year for Asterisk, and like most years, we have a release this year, Asterisk 18. So a new major version of Asterisk has been released, and there have been about 421 different code reviews that have been involved in that, and those reviews have come from 56 unique contributors. I like to always talk about those who have gone through the pain and the suffering, and I use those words a little bit lightly, that's involved in the contribution process for Asterisk. It's not intentionally hard to do, but there are a few things that make it a little bit challenging, like getting a CLA signed and things like that, that can make it a little bit more difficult to contribute to. And so I'm grateful for everybody who went through the work to do that, and not just that, but also to be very active. As you can see, that there are some people on this list that have been quite active. So if you look at the number on the left to each name, that's the number of different code reviews that person has authored or been involved with. And as you can see, there are a number of different people that have done that, and some of them within Sangoma and some of them outside of Sangoma. So that's really, really neat to see. So I just want to thank everybody who has been involved and have tried to participate in that process, not just from a code review perspective, but also, well, not just from a submission perspective, but also from a reviewing other people's code perspective as well. That's how we raise the bar as far as code quality goes, is making sure that we're watchful for what goes in and making sure that it's bug-free as much as we can. All right, so let's talk about release types. So standard releases receive about a year of, or they receive a year of bug fixes, and they receive an additional year of security fixes. And so 17 was a standard release. LTSs, they last a little bit longer in terms of the maintenance cycle. There's about 4 years of bug fixes, an additional year of security fixes as well. And some examples of that are the 16 branch and also the 18 branch, which we just talked about. So this new major release will be an LTS. Let's talk about some of the things that are new in Asterisk 18. So the categories we have today are stir shaken. These are kind of major blocks and things like that I want to discuss in terms of this topic or this presentation. There are video improvements, codec negotiation foundations, so improvements to that, and some debugging and logging improvements, as well as my favorite category, which is miscellaneous fun. And that kind of covers a lot of things that that aren't captured adequately by some of the major points in the present, and you know how I editorialize this presentation. And I think I mention this every year, but again, just to repeat, there were a number of 400 to 500 different code reviews that went into Asterisk 18, and so I get to with the help of the Asterisk team editorialize those. I can't talk about all of them because this presentation would be very, very long if I did. And so we just get to pick a few things out to discuss. And so that's what we've done. And some of them fit in some of these major themes, and others are a lot of little miscellaneous things that don't fit into one of those themes. All right, so stir and shaken. So you may be looking at this, and some of you may have a very good idea what this is, and some of you may be looking at this and wondering what the heck are you talking about. Stir and shaken are a set of standards or technologies that have been developed to help with the problem of robocalls and scam calls and things like that. Just in the course of a given day, I probably get 3 or 4 different calls from numbers that I have no idea who they are, and have no interest in picking up. I'm not sure how my number got advertised to them or how they picked it up, but I still get the calls nonetheless. So what's more nefarious is when a call comes in from a number that I recognize and I pick it up and it's not the person that I recognize. Stir and shaken are a set of technologies that are, I guess you could say they're in development, but they're coming along quite well, that keep a caller from being able to falsely claim ownership over a caller ID. So an incoming call cannot be falsely asserted to be from somebody who's not the owner of that phone number. And so there's a lot of technology pieces and parts that kind of come together to make that happen. But Asterisk, we wanted to add Asterisk support for it so that Asterisk could recognize when a properly originated call comes to Asterisk and be able to differentiate in that case so that people can start using Asterisk in their network in environments where stir and shaken have been implemented. These standards have been, they're going to be going out to major telecom providers in the US and things like that. So it's pretty important to be able to at least know what's going on as far as how you might interoperate with this technology from an Asterisk perspective. And so the Asterisk implementation allows configuration for certificates. So the way that a call is verified to be from the proper owner, like so a caller ID is associated with a proper owner, is using certificates and signatures and things like that. Asterisk has the ability to be able to both sign a call if it has access to the certificate for the owning certificate for a number, and also to verify those signatures when they come in from incoming calls, to be able to verify that call comes from, the caller ID from that call is from a source that can properly claim that caller ID. There are dial plan functions for examining the verification, and it's channel driver agnostic, although PJSIP is the only channel driver that is supported at the moment. And it's enabled on a per endpoint basis in PJSIP. From a dial plan perspective, the dial plan allows inspection of the stir shaken verification results. So when it's processing the call and trying to figure out if it's properly signed, it allows you to know from a dial plan perspective what the results of that check are, and then you can, as an administrator of an Asterisk system or as a ITSP or somebody who might be using Asterisk in a situation that you have to interoperate with stir shaken data, you can implement your own policies based on that information. So if you want to make different choices about call routing based on whether or not the verification is assured, properly passes, or if it's not passing, you can kind of make those decisions how you want from a dial plan perspective. This is part of Asterisk 18, but it will also be a part of Asterisk 16 as well, as we're able to backport this code to Asterisk 16. Asterisk 18 from video. So we talk about video every year, and this is sort of an ongoing major theme in Asterisk. So we very much care about video from a long-term perspective for the Asterisk project. And so we are continuing to improve Asterisk video support for our WebRTC first world that many of us are living in, particularly that many more people have had to get familiar with as COVID has made people work remote, and people have had to use remote video-based tools and things like that, and it's becoming more and more important. One thing that we allow now as of Asterisk 18 is multiple video sources per endpoint. So to this point, when we added Asterisk 15, when we added support for multi-stream video and things like that, you could have multiple video streams coming into your browser, right? You could display other participants in the conference at the same time, but you could only send one video stream off to the conference. Asterisk 18 removes that limitation. So there have been newer ways of doing screen share in browsers. Last little bit here, and it now allows both the camera and the screen share to be sent at the same time, so you can provide more rich experiences. We also added the ability to add, remove video mid-call. So this is a little bit complicated and a little bit technical, but so one choice that was made when we added video, sort of revamping video support in Asterisk, was that if a call started off with video support, it was okay as far as video goes. Like, you could always have that class of media in a call. But if a call started off as an audio only call, it was not possible to upgrade that call to a video call. And so obviously in most of the, in a lot of situations when you're designing video applications and things like that, usually you're just going to start off your calls with the video streams attached and things like that, or at least the video streams declared as part of that call. But in some cases, perhaps you won't. And so this allows calls to be upgraded with a video stream mid-call, which is kind of nice. And this works for video conferencing bridges as well as normal calls. Let's see, multi-stream local channel support. That's kind of word soup, isn't it? What this means is when we added a lot of the multi-stream video support in Asterisk 15 and 16, 17, we did not focus on local channel support. We focused mainly on just the standard channel types, for the most part, PJSIP. But now you can use local channels and involve them in multi-stream video dial plan applications and functionality and things like that. You can have local stream proxy for a multi-stream video session as well. So for those of you that rely heavily on local channels within your dial plan and things like that, the local channels should transparently pass through the underlying multiple streams that may be associated with an endpoint. And there shouldn't be any issues with that. We've also added some packet loss improvements. So we, as an Asterisk team, we regularly use, actually daily use Asterisk for our daily stand-up meetings. We use Asterisk with video calling for that. And so we get to see how it operates in a lot of different conditions, a lot of different network environments. And so we are always looking for better ways to tune how we handle video, how we improve the video quality experience, especially in bad environments. And so we've added some code to be a little bit more aggressive at sending packet retransmission requests, or NACs, to get those missed packets quicker and reducing the amount of potential video freezes that you may have in poor network environment, as well as also having growable buffers for extreme network conditions. So when you have really, really poor network conditions, the buffers are now a little bit more dynamic in terms of the packet retransmission buffers. So those both are ways that we're trying to improve the video quality experience, particularly in bad environments. Codec negotiation improvements. Let's talk a little bit about this. So this is something, so the codec negotiation, the way things have worked in Asterisk as far as how you specify which codecs are allowed and disallowed, that's generally worked the way it's worked for a very long time in Asterisk. There were some improvements a number of years ago to allow you to specify some preference orders with regards to when you're configuring an endpoint, like for example, PJSIP or ChanSIP, you can set your allow line to a couple of different audio or video codecs, and you can disallow some others if you don't like. And you can also, Asterisk tries to respect the ordering that you input them into the allow line. But the one thing that has been a challenge is that those configurations options only govern the negotiation of how Asterisk talks to the endpoint, or how it negotiates with the endpoint. It's not necessarily passed through between, let's say if you're just terminating a call with Asterisk and you're not bridging it to another endpoint, like if you're not forwarding, dialing another phone or something like that, then that's all fine and dandy. But as soon as you introduce another device outside of Asterisk, you want to be able to better negotiate with that other device, because there may be some, preferences the other device has that allows you to, as far as codec preferences, that if you passed it through end to end, you could, potentially eliminate transcoding, potential Asterisk transcoding situations and things like that. And so we've added some improvements to be able to, at least to the core of Asterisk. So this is foundational work, but to the core of Asterisk to be able to pass through a lot more elements of the codec negotiation process between endpoints. So if one phone is being bridged to another phone or calling another phone, a lot more of the codec negotiation preferences are passed between those two endpoints so that they can make a better decision together as to what codec makes sense for both of them. And this allows you to do things like set up your home office to be able to run a high quality codec like G722 or Opus between all your phones. And usually providers are only MULA or EULA or perhaps ALA, which is a lower quality codec. In that case, if all your phones were set up to do 722, you may have to transcode on the leg up to your provider. Like if a phone wants to make an upstream call to provider, this might incur transcoding. This would help to eliminate cases like that. So making less system load on Asterisk for perhaps needless transcoding in some cases. Let's talk about the PJ-SIP logger. So for those of you that have debugged SIP traffic with PJ-SIP, it works. You can dump SIP protocol traffic to the console and you can see that traffic. And that's, that's good and that's fine, that's dandy. But there are, some people like to use other tools for debugging SIP traffic. Some tools like Wireshark and things like that provide really, really nice user interface for being able to visualize traffic flow and the different endpoints that are potentially involved when you've got multiple, multiple calls or multiple different entities involved in a SIP call, like where media might be going to different location versus signaling and whatnot. So we've added support this last year for native logging in the PJ-SIP logger to PCAP, which, for a lot of people, this could be really important, especially if you have to debug SIP traffic all day. So all traffic is logged unencrypted. So if you're using secure SIP signaling, that can be a challenge sometimes if you're trying to use TCP dump or something like that to figure out what's going on with SIP traffic. And so it's logged unencrypted, so that allows you to get around that. And there's a strong possibility in the future that we may add media support as well. So this applies only to signaling, but at some point we could definitely see this being useful for media as well, so RTP-based media. All right, so let's get to my favorite category, which is miscellaneous fun. Actually, they're all my favorite categories, but miscellaneous fun. So ARI channel create now accepts dial plan variables. So now you can add dial plan variables to the create of a channel from ARI. And for those who are not familiar, ARI is Asterisk REST interface. So the ability to control Asterisk with a REST-based API. We've added improved ICE handlings. So ICE is used in WebRTC call connections. So when browsers are calling Asterisk or Asterisk is calling browsers, ICE is the technology that's used to connect the media between a browser and Asterisk. It has some advantages over just using RTP without ICE. So ICE is sort of at a layer outside of RTP. But Asterisk has supported ICE for a long time. But now with ICE handling, we will send media, we'll start sending media as soon as at least one valid pair is found, which is kind of nice. It improves call connect times, or it lowers call connect times, so the time that it takes to have media, a media connection on a call. And so it makes calls come up quicker and things like that. We also added in PJ-SIP identify types for those that use that with providers and things like that, that they can optionally match on IP address and port, not just the IP address. The Res Music on Hold module now has support for a playlist mode, which is kind of cool. It allows you to specify which files in which order you would like to play on your music on hold. We added support for H.265 and HEVC, as that's becoming, kind of a more implemented thing from the browser front. So there are video codecs that allow you to be able to use a lot less bandwidth and get higher quality for a similar bit rate. We've also added a maximum sample rate configuration option for conference bridges. So ConfBridge, the Asterisk conference bridge, has always been able to handle dynamically which sample rate it should be mixing at. That way, if you've got really high quality participants, so ones that are using like Opus or 722 that have really high quality audio codec, they can perceive the conference at a high, high sampling rate. And then if you have lower quality participants, like maybe a 711 or something like that, then they also can be involved, but the participants are upsampled to whatever the high quality rate is, the highest quality rate is for the conference. Just so that you can sort of cap that, we've added a maximum sample rate to Conference Bridge so that you can potentially not have to burn as much CPU by sampling everything at 48 kilohertz or something like that, because it is a lot more work to sample at 48 kilohertz versus like 16 kilohertz or 8 kilohertz. So that way that the bridge sampling rate can be capped. Just a reminder, Asterisk 13 is now in security fix only status. That branch has been around for a long time. It got a little bit more, or got a little bit extra time compared to normal LTSs due to some unusual circumstances. Additionally, 17 has also transitioned to that phase. Asterisk 16 is LTS and it goes security fix only in 2022. So if you haven't moved to 16, get moved to 16, but maybe better move to 18. And then final bug fix releases for Asterisk 13 and 17 will be happening shortly. And those will be the last bug fix releases for them. Also keep track of what's going on in newer major releases of Asterisk. Some people go from LTS to LTS. While generally as a project, we try to operate by the principle of least surprise to our user base. So we try not to change things out from underneath people. Or if we do add support for something new, we try to hide it behind a configuration option and things like that, so it doesn't break compatibility with dial plans and whatnot. But occasionally we miss something, and so it's good if there's some critical functionality that you depend on that maybe we didn't catch, that you're checking releases as they come out, particularly the standard releases. ChanSIP continues to march to an end. So last year we announced that ChanSIP was marked as deprecated as of Asterisk 17. And so it's a good idea to move forward to ChanPJSIP as soon as possible. In fact, it's probably should have been a long time ago. But as far as Asterisk 19, so as of Asterisk 19, so the next major release of Asterisk, ChanSIP will not be built by default. This doesn't mean it won't function, but it will not be built by default or be enabled as a build, as a default build option. And then just keep track of what's going on as far as the Asterisk versions wiki page so that you know when your particular branch of choice or what version you're running goes end of life. That's a good resource. All right, so I've talked a lot about Asterisk. Now let's change hats and talk about FreePBX and what's going on with this project. Let's see what's happened this last year. So we have been wanting to improve some testing foundations with FreePBX. So this happens in a lot of different ways. From an Asterisk perspective, we've got really great unit tests, we've got functional tests, and we've got the different QA groups at Sangoma that use Asterisk as an engine for different products. They all are involved in testing Asterisk. From a FreePBX perspective, previously we had a shared QA group with a lot of different pieces and parts of Sangoma. We now have a dedicated QA group for FreePBX testing. And so this is good also for Asterisk because this will be another front that they're able to find potential issues with Asterisk as well. We're also continually evaluating ways to improve our unit test coverage within FreePBX and its supporting infrastructure. We would love to increase our unit test coverage. We'd also like to see our testing frameworks improve as well. So potentially doing like functional testing and things like that. So these are some areas that we've been trying to address and would like to continue to address as well. We've also been providing improvements throughout the year instead of, trying to make, or I guess, instead of trying to make everything new come out at once, if there are things that make sense and aren't going to break a major branch of FreePBX, like 15 or whatever, then we try to merge those changes into FreePBX 15 in particular. We've been trying to merge those changes in so that things don't catch people by surprise when they upgrade, like once every couple of years and things like that. This allows the changes to be tested and fixed sooner rather than waiting multiple years and everybody being surprised and things like that. So it's been generally we've seen some good results with this. So let's talk about some technical things about what's happened this last year. So we had the module master signing key update. So we decided to add support for an additional module signing key in FreePBX land. It's a bigger key. It's a 4 kilobit key length, and this allows us to potentially have a stronger key that's involved in that module signing process. This doesn't mean we've sunset the old key, but it does allow us to have this as an option if there was a need to sunset the old key. There was the call accounting module release for FreePBX, which allows you to better track different users or departments that are making phone calls and figure out, be able to track how much usage the different users and departments may be using on the phone system, so you can better account for those things. When you get a big bill, you can figure out which department was the one that did it. Let's see, there's emergency calling improvements, and there was a talk about that by Walter Moon at this AstriCon, and generally trying to improve the experience as far as compliance with some US-based laws around emergency calling, Carey's Law and the Ray-Balm Act. That was really important, as there were some very important deadlines this last year as far as being able to comply with them. And so we tried to make some improvements to FreePBX so that it was easier for administrators to comply with those technical requirements. We've also continued to invest into backup and restore. So as part of FreePBX 15, one major piece of that was rewritten backup and restore functionality. We want to continue to invest in that. We don't want that to be a one and done thing. We want to continue to make that better. We want to, as people find strange situations that were unanticipated in the beginning as far as backup and restore scenarios, we want to continue to improve that and make it solid, because it is a very, very good way to migrate forward with FreePBX. Let's see, we additionally added support for, it's called warm spare support. And that makes it easier to set up a warm spare configuration with FreePBX. And kind of along the same theme, we released the advanced recovery module, which makes it a lot easier for an administrator to be able to set up a warm spare system and be able to configure it with all the different phones and endpoints that may be involved for failover between the systems and things like that. So that was kind of a big thing. Let's talk about some endpoint related things. We added support for a CLI conversion tool for bulk conversion of SIP endpoints to PJ-SIP. We added some improvements to Endpoint Manager for reprovisioning endpoints to PJ-SIP. So if you change an endpoint from SIP to PJ-SIP, it will take all the right steps to be able to get all the provisioning configuration information ready for the endpoint, and then send a reboot command to endpoints that support it to be able to reboot as a PJ-SIP endpoint. So that can make it a little bit easier to handle when you've got remote endpoints that you don't have physical access to. We also added support for custom firmware management in Endpoint Manager, so that if you'd like to, you can add custom firmware updates and things like that, even ones that have not yet been through the QA process on the FreePBX side if you'd like to have that level of control over it. We've added support for Let's Encrypt certificate multi-perspective validation. And that's another item of word soup. But basically it means a newer version, or the Let's Encrypt infrastructure now challenges servers that are using, so the way that it handshakes with servers to prove that you're legitimate and that it wants to keep allowing you to use your certificate and things like that. It used to do it, I think, from a single address, and that changed at some point, and it caused some problems with the firewall module in FreePBX, and it can come from lots of different addresses. So we added some code to handle that case. We've also, on a little bit more on the endpoint front, we've added a product called Sangoma Connect, which is sort of a next generation of the Zulu mobile client. And that's been talked a little bit about on forums and in other places, but you can read more about it there. Astra 17 support was added to FreePBX. So if you want to run Astra 17, you can do that. And we had the PBExact 15 release this last year for those of you that are running PBExact. Here are a few things, just a couple things I want to touch on. This is from the community front, but there have been some logging module improvements that went in, which I was really excited to see from the community. Add support for autotail and regex searching and things like that, which is really great functionality to improve that experience, as well as there were some general firewall improvements that went into FreePBX from the community as well. All right, so let's talk about what's next. FreePBX 16, right? So that's probably something on everybody's mind. It's been, I think between 15 and 14, there was a good chunk of time. It would be nice to not have quite as long time between 15 and 16. So we would love to see a FreePBX 16 in the first half of 2021. So you may be asking, if you're adding, new features and function, or to some extent, features and functionalities to FreePBX 15, what would a 16 entail? Like, what would that mean for FreePBX 16? And I would say to you, that's a great question. So let's talk about that. So things that would justify a new major release are things like that are probably very core to FreePBX itself, right? One of the things that might potentially break aspects of FreePBX or some of the core parts of FreePBX. And so one very, very big thing that's been wanted for a while is PHP 7.x support. This is really, really a big deal. Actually, there's been a lot of work on the community front. So Bill Simon and the community has been working hard on doing this in the open source front. But there's some, as far as the commercial modules go, there are some updates that we have to make on inside, as well as the commercial module infrastructure that we needed to address to be able to support PHP 7. And so that is something that is probably a big part of FreePBX 16, what we want to see in FreePBX 16. And not only is it's not just a version number upgrade, but also there should be really big performance wins as well as security wins. There have been a number of performance increases in PHP 7.x that we would like to take advantage of that should improve the user experience, should make things faster, should make things better, and things like that. We're also working on updating the distro to SNG 8. So we want to get a newer version of the Sangoma distro. And currently it's based on CentOS 7. We want to get it moving forward to CentOS 8. So that's something that we are working on to, as far as the distribution. So you may say, okay, la-di-da, updated distribution, whatever, right? The implication of that is also you get updated Apache databases and all these things, like where you get new versions, you get performance updates, you get bug fixes, you get a lot of other really important things that FreePBX as a system gets to take advantage of, and you get to see those improvements as a user. Let's talk a little bit about the FreePBX forum. So we talked about the Asterisk forum. Let's talk about the FreePBX forum. There have been over 29,000 new posts this last year on community.freepbx.org, and over 1,400 new contributors. That's a lot. That's a whole lot. That is definitely, I think, an indicator of a very active community. All All right, let's talk about some other fun community things that are going on. So we have open source lounges about once a month. It was about bi-weekly, but we swapped it to once a month. There's an opportunity to talk with members of the FreePBX dev team and others that work at Sangoma about FreePBX and about different topics. You can talk about Asterisk, and you can ask questions. And there's a lot of really smart people, not just the FreePBX dev team, but there's tech support people there. There's a lot of really, really smart and experienced people that are there that can help if you got to bounce an idea off them about something. That's a great opportunity to do so. If you'd like to sign up, if you'd like to present something at an open source lounge, there's a link that's attached to this slide that you can see. And you can submit a topic potentially that you'd like to maybe talk about. So there's the opportunity for just about everybody to be involved, whether it be an impromptu discussion or you want to have a structured conversation about something. There's different options available. Also, I want to reiterate, ChanSIP continues its march to the end. So move to ChanPJSIP when possible. So yeah, it's the same problem on Asterisk front and FreePBX as well. There have been a number of tools I talked about before that we've hoped to make the migration to PJSIP easier, but this is really important if you want to be on a channel driver that receives bug fixes still, and security fixes and whatever, it's really important to get on PJSIP. Also, please move forward to FreePBX 15. Backup and restore should make this very easy to do. We've tested it against a wide range of scenarios. It works definitely. The initial release of FreePBX 15 involved 15 down to 13. And we've continued to further that support, and we should be able to support versions prior. Now in FreePBX 15, we should be able to support versions prior to FreePBX 13 as well. So there's been a lot of really good things that have been happening there. So please try it out, and if you see an issue, be sure to raise a ticket on issues.freepbx.org. And community.freepbx.org is a great place to ask questions. So there's a lot of really smart people that can help if you are trying to set up a new FreePBX system or you don't understand something. It is a great place to go and ask those questions. I just want to thank all of you for taking the time to listen to me at the end of the conference here. It's been definitely an unusual year. COVID's kind of changed things. It's an unusual AstriCon as well, right? It's all remote and virtual and things like that. But we felt that it was important to still kind of bridge the communications gap with the people that do use AstriCon as a way of figuring out what's going on with the Asterisk project and potentially FreePBX project and other things that are going on at Sangoma. And so we thought it'd be best to be able to continue despite the challenging circumstances that everybody's in this year. Hopefully there was something interesting or informative that you got out of this presentation. And I think that's it. Thank you.
Hello, everyone, and welcome to the live Q&A with Matt Fredrickson and his merry band of bandits. Matt, take it away.
Merry band of bandits. Okay, sorry, Julie. I had to laugh for a second.
But it's all you. You guys.
They're not bandits. Yeah, okay, so thanks very much, everybody, for listening. For those of you that made it through to the end of the conference, it's always tough having a time slot at the very end of a conference because everybody's brains are already washed out. People aren't thinking clearly anymore. Usually you had a conference party the night before, and everybody's just trying to make it to the end. And so for those of you that actually have made it this far, I very much appreciate you guys' attention, and so I hope we provided some value in terms of what you're trying to learn about this on the Asterisk and the FreePBX front. So I have here with me members, not everybody, but I have some members of the Asterisk team and I have some members of the FreePBX team. If you're on the Asterisk team, please raise your hand. All right, and if you're on the FreePBX team, please raise your hand. Thank you. All right, so we have adequate representation from both camps. So when somebody asks me a whopper of a question, I've got a little bit of fallback here. That's the real reason we're all here, right? All right, no, actually, I'm glad they're all here because, you know, these are the guys that actually do all the hard work. Well, I mean, they're community members as well, but on the Sangoma front, these are the people that are doing a lot of the hard work to contribute and move both those projects forward. And so we want to make sure we have representation from those projects since we're talking about those today, or I talked about those today. All right, so I guess let's get started with questions that have come up. I tried to take note of them as they were scrolling by in the chat. And there were a few questions. Some of them may have gotten answered, but I'll try to go through them. Josh, do you want to talk about the first one? It says, why are you still patching and fixing legacy versions back to 13.x? Would it be simpler to sunset support for legacy code to force/encourage updates?
A policy question. When did my life become such that I actually enjoyed policy questions? I don't know. But as a project, we have policies in place for various things. One of them being for versions. So within the Asterisk project, we have long-term supported releases and standard releases, and each of those are supported for a different period of time. So in the case of Asterisk 13, in fact, that's a long-term supported release, which would have normally been supported for 4 years, but we actually extended it an extra 2 years to give ourselves some time to better finalize some of the video work that was actually done. Just a heads up to everyone, Asterisk 13 itself, as of this Saturday, is actually going security fix only, meaning that it will no longer receive bug fixes. And for those who may not have known this previously or who want to know about other versions, on the Asterisk wiki at wiki.asterisk.org, at the top of the page, there's actually a link called versions that you can click, and it'll give you a nice handy graph with the Asterisk versions and then the dates when various things occur, along with a description. So if you're using Asterisk 16, check out that page and you'll see exactly when it will be supported too. So 13 is going bye-bye. We wish it well. It's been a great version, but if you're on 13, now is the time to put together a plan for moving to Asterisk 16 or Asterisk 18.
That was a great update, Josh. Thanks for clarifying that. And just so everybody else is aware, Josh, I don't know why those two words would be commingled in my head. So Josh actually is the technical lead for the Asterisk team at Sangoma, and so he drives a lot of the day-to-day direction of that team. And so it was good to have that update from you, Josh. All right, our second question is, will these stir-shaken signatures be supported by most SIP provider? And that was from Sunny Sunday. And I'm going to let Ben, would you feel comfortable answering that question?
Yeah, sure. So unfortunately, that's probably going to be on a per provider basis. I know that some providers now are already kind of testing that between themselves to set up that chain of trust. Unfortunately, it's just going to be whoever provides it, whoever doesn't. If there's going to be a provider that puts that identity header on there, that certificate, and sends it to somebody who doesn't support stir shaken, they're just going to read it in as a normal SIP message. It should be fine. But if it's going in the opposite direction and you have someone who doesn't support stir shaken trying to send or trying to place a call to a provider that doesn't support that, or that does support stir shaken and is looking for that identity header, then that's when it's going to run into problems. So unfortunately, that's going to be on a per provider basis.
Thanks, Ben. All right, let's see. I moved my question window. Okay, so somebody asked, what's the state of Switchbox? I haven't heard much mention, if any, at this AstriCon. Is FreePBX the option more people are going for? I would not say that that is the case. I think probably the reason why you've heard talk other than Asterisk at an AstriCon, from our perspective, is so generally AstriCon is about Asterisk, right? But a lot of people from open source Asterisk, right? So Asterisk is an open source project and product. we have, in the last year or two here, we've started, since, Sangoma and Digium became one big happy family. There were kind of two big open source projects under the same umbrella at that point. And so we decided it was appropriate probably to discuss, FreePBX updates and things like that, since it also is an open source project. So I guess that's just sort of frame my response. But yeah, I guess we didn't really have an update as far as SwitchFox goes specifically. If there's a general interest in that, as a kind of a closed source product or whatever, I guess that's something we could reconsider. I don't think we had a commercial track, like a true commercial track this year, which probably would have been the place where an update like that would have happened. But it's good feedback, and I'll pass it back to the product manager over SwitchFox and let them know that was missed. All right, obviously, this AstriCon this year, this was it was the product of a large number of compromises. It was how do you provide a reasonable update to people with what's going on generally in Asterisk land, in a virtual conference, which has its own pros and cons too, right? And so, I think we probably have a lot less talks this year as well in general. So, all right, let's move on to the next question that I saw. It says, are there plans to update the Zulu desk client to get things like BLF contacts, etc.? Unfortunately, I am not the product, so I am responsible for FreePBX, but Zulu as a product is owned by a different part of the organization. And so I can't speak for that specifically. So you'll probably have to contact maybe product management, I guess, on the Zulu side to discuss, kind of whether improvements like that are going to be pushed out going forward. All right, so I went through all the questions that I noted in different chat rooms during the talk. Let's see, there are probably a few more that I missed that I should let you know.
Yes, I'll grab, well, you do that. I'll grab one from YouTube chat.
Sure.
There's one about being on Asterisk 14 and needing video support and moving, and whether to choose 16 or 18. 16 itself will be supported from a bug fix perspective for the next 2 years. However, 18, having just been released, will be supported for 4 years. So I would suggest making the jump to 18 so that you don't have to quite make that jump again so soon.
Thanks, Josh. That was, I think, the right answer. Somebody else asked, actually, it looks like, George, it looks like you answered it, but I just, I guess, covered over the air. Current SwitchFox PBX. So what version of Asterisk do we run SwitchFox on? George, do you want to verbalize your answer?
Yeah, SwitchFox currently runs on certified 16.8. So it's on the current long-term release branch.
Yeah, they and actually SwitchFox keeps very much up to date in terms of latest certified and things like that. So it's, I think it's a testament that things have really gone far as the testing process for the test framework, unit test framework, functional test framework for Asterisk, as well as the qualification process on the SwitchFox side for qualifying new releases. So, all right, let's see. Let's go down through the questions. I think I went too far. If anybody else sees one from this group, if you see a good one to grab, feel free to chime in.
Is Asterisk 18 support and FreePBX 15 today? I guess I'll let Jason answer that.
Yeah, so I actually just posted a link in chat. The issue number is FreePBX 21962. It was actually created during our AstriDevCon thing. So it's going to be fairly easy to do. It's just someone needs to get on it. But there's a request for it. There's an issue tracking it. So it should, I would imagine, be done relatively soon. I think that's more of a Lauren question, specifically when, but I can't imagine it'll be long.
Yeah. Yep. All right. Let's see. Are there any other good questions that anybody was able to retreat? Sorry, I'm looking at the chat room again. Awkward pause, right? There was another one that said, what's replacing ZenGuard in FreePBX 16? That is a highly technical question. So For those who aren't familiar, we use Zenguard as part of our commercial module packaging process. It's incompatible with PHP 7.x with current versions of PHP. And so we're moving off of it to, it's probably okay to talk about, but I think we're moving to, I think it's a product called IonCube for providing similar functionality. So that's kind of the direction it's going to take from a project perspective.
Matt, there was a question on the YouTube chat about features planned for 19.
Oh, that's great. Yeah, I guess there wasn't a similar, so FreePBX is kind of in the middle of a cycle right now. So Asterisk went from one release cycle to the next. Like we got really standardized annual release cycles, right? And so usually the way that planning process works is we make our major release at AstriCon, and then we kind of begin the planning process for the next major release. And so to a large degree, that planning process hasn't begun for the next major release. Now, there are some major themes that that cross releases that are kind of important from a project perspective that we've been continuing to push on. And so you can kind of trust that there's going to be effort in those directions along with whatever directions are pushed on. Those directions are things like ARI. So the REST interface for Asterisk is very important. We're continuing to be working on that. PJSIP as well. Continue to make sure that there is no good reason for somebody to stay on ChanSIP. So PJSIP should be first and foremost in terms of choices, and there should be no technical reasons to be off of it. And then the video work has been a cross-release theme as well. The last few releases and trying to push that forward, because that's now obviously in the last 6 months or so, that's definitely proven to be, practically very important, right? And I'm trying to think, did I miss anything else, Josh, from an Asterisk perspective?
No, I don't think so.
Okay, that was a good question, George. I'm glad you passed that one up.
There was another question in the Slack from Bill Simon. It says, what is the best way to influence new feature requests for either Asterisk or FreePBX? Which I think is a pretty good question.
That is a really good question. So I would say, I'm going to give the answer that a lot of people don't like. So many people don't like this answer, but I know that Bill has development shops. So the best way to influence new features is actually to contribute them. So if you want to influence the direction of an open source project, the very best way is to make it happen, right? To submit features and to push them forward and get them merged as part of the code base. Outside of that, there are a lot of competing and separate interests that are involved in open source projects. FreePBX has a lot of representation from Sangoma. Asterisk has also a lot of representation from Sangoma pushing those projects forward. There are individuals outside of Sangoma also that work on those projects. So you can either try to solicit members of the community that may have development experience or development desires to try to push it forward. Additionally, from a project planning perspective, as we're going and trying to figure out future and what we're trying to do, we generally try to be mindful of things that the community has major concerns about as well. So we try to make sure to address major concerns on the community front as well. So things that might be major concerns or good avenues for direction on the FreePBX front, those are great things to talk about on the community forums. On the Asterisk front, those are great things to talk about on the Asterisk development list. At least that's what that's what I would suggest. Josh, do you have anything to add to that, or do you think that there are any additional areas that might be worthy to pursue as far as pushing direction there?
No, nothing else comes to mind.
Okay. All right.
There's a chat question about is Sangoma maintaining their own code base for PJSIP?
Oh, that sounds like a George question right there.
Actually, what we do is we do bundle PJSIP with Asterisk, and that is the preferred way to deploy Asterisk, because now we have a known and controlled version of PJSIP underneath. But we take those tarballs from Telu, who are the maintainers of PJ Project, and any enhancements or bug fixes that we do to PJ Project, we always push back to Telu for them to include in their normal distribution. Right now, we don't have anything custom in PJ Project that we have not pushed to Telu.
Thanks, George. And by bundled, so there was a time when we actually had the PJ Project source code within the Asterisk source tree. That's not the kind of bundled that George is talking about. Do you want to clarify a little bit on that as far as what it means, George?
Yeah, so in Asterisk 11, we actually did have a version of PJ Project that we cloned at one time and included in the Asterisk source tree. That's long gone. For, I want to say maybe about 3 years ago, maybe 4 years ago now. What we do when you build Asterisk with bundled PJ Project, we actually download the tarball from Telu's repository, expand it, apply our own patches, and then you build Asterisk. And of course, those patches are the things that we always submit back to them. So for instance, every time, let's see, we're at PJ Project 2.10 now. If they release PJ Project 2.11 tomorrow, we probably won't have any patches, any custom patches left in our repository because we've already given them those patches and they've included it in their normal code base.
Thanks, George. All right, let's see. Do we have any other questions that I missed?
I got a question about if there's a bounty program for bug fixes.
Oh, that's a great question. Josh, do you want to talk about the Astra side of that equation? I think we had a discussion about it actually at AstriDevCon on Tuesday, but
Ben kind of answered it. Why doesn't he repeat himself?
Sure. So Sangoma itself does not actually offer any bounties for bugs, but if there is a community member or you need a bug fixed, you are more than welcome to post a bounty, and anyone from the community can take you up on that offer.
Thanks, man. So yeah, I mean, so on the Asterisk front, we've got a wiki page that talks about how to do it and you know, how to access potential developers that want to do that. But yeah, there's definitely the opportunity to solicit community developer interest as far as bug bounties and things like that. All right, any more questions?
Well, Matt, it looks like you guys have taken everyone through the questions in Slack and on the live chat. Thank you, gentlemen, for being with us. I know it's completely different than what we're used to, but you guys have made it an enjoyable event. And I'm so glad that you were all able to join us today. Need to remind everyone to save the date because next year, 2021, AstriCon will happen September 28th to the 30th at the Lowe's Royal Pacifica in Orlando. It's going to be a few weeks earlier than normal, so make sure you jot those dates down because we really want to see you guys all next year face to face.
And if there are any more questions that come up, we'll probably be monitoring the FreePBX Slack room and on the public chat, and we'll hopefully be able to catch some of those if people need some time to think.
Thanks, guys.
Thank you for joining us for AstriCon 2020. We hope you will join us in person next year as we head to Orlando, Florida. Save the date, September 28th through 30th at the Universal Studios Lowe's Royal Pacific Resort. Stay safe and see you next year.